specifically me and my team are waiting and including my participants because when we are together, we are all learners. So irrespective of what designation or irrespective of what platform we are. So as a learning student, sir, we are waiting for your wisdom words, which will
Yeah,
be
sure.
very informative and will be very helpful in research, obviously
Definitely.
for
Yes.
my team also. Thank
Yeah,
you,
yeah.
sir, and welcome. And you can please start the session. Thank you,
Yeah,
Dr. Mamta. Please carry on.
Yeah, thank you, ma'am. Thank you for your constant guidance, encouragement, inspiration always. So, the topic of today's session is Insight into LLM, which will be conducted by Sir Anand Kumar Sir in both the sessions today, as already told by ma'am. LLM, which is large language models, form the very foundation of modern artificial intelligence, whether it's a chat GPT, AI, or any other advanced AI system like we are exploring for the past 3 days in our FDP. So it often makes us wonder, are LLMs smarter than humans, or the humans are smarter for being able to create and use them so effectively? So let's dive deeper into the fascinating question with today's expert speaker, Anand sir. He is an associate professor of NITK with over 12 years of teaching experience. Sir has completed his PhD from Amrita Vishwavidyalaya and his research include natural language processing, social media, analytics, machine learning, deep learning, and many more. He has published and presented over 20 research papers in Scopus and SI Index journals. He has also edited several books, including deep learning techniques for natural language processing and many more. So, without further delay, let us begin today's session and gain deeper insight into fascinating world of large language models. Before we begin, I want to have a small request to all the participants. As already told you, that sir is going to take both the sessions. So let's make the session more interactive and engaging as possible rather than listening passively. I'm sure today's discussion will be thought provoking and insightful. Anand sir, over to you, sir.
Yeah. Thank you, ma'am. Yeah. Thank you once again. Thank you, Mamta ma'am, as well as thanks to our director, Maninder Kaur. So thanks for your invitation. So as ma'am rightly pointed out, and then we just make a kind of an interactive session. So I don't want to, because already we know that how we bored when you are sitting in a last hour, how students are getting bored when they are sitting in a seventh hour or eighth hour, right? So this is not a eighth hour or seventh hour. This is a, we are starting in the 10th hour, right? It is a very odd time. But I'll make the session more interactive, but the interactiveness is not only from my side. I want participants to interact with. So we'll keep it like a discussion session, and then we'll proceed. Actually, you can, because I have some experience with the NLP, the foundation of large language models. So that's what we used to say. It's a natural language processing. So I'm working in this field for a few years. So you just make use of me. Whatever doubt you are having, that we'll discuss it. So I'll just go to the session without wasting my time. I'll share my screen. Yeah, I hope my screen is visible, right?
Yes, sir. Yes, sir.
Yeah, thank you, ma'am. Yeah. So, so the first session, I'm going to talk about something called very important things to large language models, word embeddings. So how we are going to use, or how we are going, what is the purpose of word embeddings in large language model? That's what the session. This will be little more technical. So I'm not, I know that actually, so this is not, I mean, even though this is a technical topic, I'm not going to too much technical. I'll just explain in a way how we are teaching to the students, so you can easily understand that what is word embedding and what, how it's related to large language model. So before going to the topic, so why this is important. So if you see that most of us as well as students, we are in day-to-day life, we are using large language model for the purpose of summarization or writing something or generating something, so, or you can say simplifying something. So we are using, but we are using it like a black box, right? So we don't know what is happening inside. So this talks will give you the insight. As I said that if I want to explain the whole LLM, definitely we need a day to explain, because this is a kind of a complex architecture. I'm not going to take the complete thing. I'm going to take a very few basic fundamental models. We can say we used to call this the foundational models of large language model, right? So as I expect that the if you have any issue with my voice, or if you are not seeing the slides, feel free to stop me at any time, and please be with me. So we will at last. I would like to show some of that LLM graphically. I'll just visualization of this LLM. I'll show that. So we'll take it a kind of discussion session. As I said, that if you have any questions, you stop me at the same. You stop me at any time, and then you can ask. So be interactive. I know that there may be some restriction in switching on your microphone and other things. So I request organizers, if someone want to interact, you please allow them to talk. So because then we'll make it a kind of interactive session. Fine. Uh, so I am, as ma'am said, that I belong to NIT Karnataka. So this is okay. I don't have that map of that Karnataka. Fine. So I'll show that. So this is a the institute is in a near to Arabian Sea. Actually, it's in a sea. So it's straight to the Bangalore. Bangalore is, you see that Bangalore is a kind of center part of the India, southern India, and this is Mangalore, or the NIT, our institute is left side to the Bangalore. So we have something called Scalar Labs. We have a research lab called Scalar, Social Computing and Language Analytics Research. We are mainly working on natural language processing, data analytics, as well as we started working on large language models and RAG system. So just brief about quickly brief about our the things. Two active projects we are involving on. So one is with respect to legal domain. So this is the ANRF project. So we are working on identifying similar documents as well as summarizing documents. So that's a one thing. The second one is actually we are working on an interesting project where we are interacting with school children. We are giving awareness to the school kids about AI. But right now we are doing only for three states, southern states. So from that we are around 15 schools we are covering in the 30 schools we are covering from each state. So this is our project. Okay, so this is a roadmap of the first session. So this is, as I said, it's only the first session. Second session we'll go into the generalized LLM application, like kind of thing. We'll say that. Okay, now as I said, if you see my first slide, I'm talking about something about word embedding, right? So you can see here, so word embedding, right? So I want you to say that if anyone heard about this term, word embeddings, participants. So I'm happy to listen you, or if you want to answer in the chat bot also, it's fine. I'm looking the chat bot. Anyone heard about this word embedding? Sometimes we'll call this as word representation also. If you couldn't switch on the microphone, please answer in chat.
Hello, sir. Good evening.
Yeah,
Nilesh
good.
Dokania from Guru Nanak Institute of Management, sir.
Hello, sir. Nice to
Hello,
hear
sir.
from you.
Thank you, sir.
It's a
Sir,
word. Yes, sir.
yeah. Just I have some awareness about word embedding to LLM.
Good.
That is in NLP, the words are in semantic. When we represent in semantic type of representation, we
Yeah.
the words into some type of numerical values or
Correct.
numerical
Yeah.
representations in that.
Yeah. Thank you. Thank you for your straightforward answer. So
In
you made a
that
hear about.
document
Yes,
Detailed
sir.
representation kind of thing in
Yeah. The representation.
word to
Okay.
numerical representation in detailed way.
Okay. Okay. Fine. Yeah. Thank you, sir. Thanks for your answer. So, if sir said the exact one word I'm taking from the sir answer, he said that the representation of the word, right, or numerical representation. If you see this first slide, you can see I have some documents. This I'm calling as a text documents, and I'm giving to some algorithm, right? So this we will call it as a deep learning or neural network or deep neural network algorithm. We have a documents. We are giving that documents to the neural network algorithm, and we are getting some answers. So this I'm saying that answers or output. The output, if you see that how the output is, I have a word cat, and I'm telling that cat is equal to some numerical representation, right? It's not a single number. You can see that this is set of numbers. So I'm saying 0 0.7, 0, 6, like that. It's a set of numbers. We can call the set of numbers as vectors, right? So the simple thing is the word embedding is alternate term to something called word vectors, right? So you know the mathematical vectors, right? The scalar means we are talking about a single word. Vector means we are talking about set of words. So what is this word vectors? How the mathematical the things are related? Okay. Yeah. So the word vectors, right? So the word vector says that the word we are converting into vector. So it means that whatever document you are giving input to the model is going to identify the words in your document, and it's going to convert into vector. Vector means numerical form, right? This is what word embedding. This is a very, very basic and very important concept in large language models. We'll see that why it is important, and then how it's help how it's help how it's helping the large language model to get the output. All those things we'll see that. Fine. So if we, as I said about word embedding, right? So the word embedding we have seen three terms. We have seen word vector, word embedding. So the same thing we can call it as a popular algorithm, word to vec. Vec means a vector. Word you are converting to vector. I'm saying that word to vector. I'm converting word, each word in your document to vector form, mathematical vector form. This is what we are calling vector way. Okay. So is it an, as I said, it's related to the large language model. So what is before vector way? So we need to know that what is before vertex. At the same time, we need to see that what is after vertex, because vertex is not the recent concept. Vertex is an algorithm invented in 2013, right? So I'm just going to brief now what is before 2013 happened, how people converted word into numerical representation. What happened after? It means that what happening now in a during LLM era, how people are converting word into vectors, right? This is what this current session we are going to talk about. Fine. So if you closely see that the word to vec, you can always ask a question, as I said that, right? You can always ask a question, why I need vectors, sir? Why I have to convert into vector? What is the purpose? Some purpose it should be there, right? Why I want the vector? Why I want to convert into numerical form? Can I use the word as such? Right? That's maybe the question you may ask, right? Okay, so the answer here is why this is. So any topic, if you want to learn that, you ask yourself, you find out why that is, right? Okay, the answer here is why this we need. If you see any machine learning or deep learning algorithm, or if you take any AI models, if you take, right, AI algorithms, commonly I'm saying that. So all those things are mathematical models, right? So mathematical models in the sense that I need some numbers to get into to calculate or to compute something. Am I right? So those are mathematical models. So your LLM is a pure mathematical model, right? So because the algorithm will work with only numbers, as it is a max, I'm going to send some numbers. I'm going to send some numbers to this algorithm, and this algorithm going to produce or generate another set of numbers, right? So here in LLM perspective, we are talking this as in a text perspective, I'm calling this as a word. Here I'm giving a something called a word, WORD, I'm saying the word. I'm converting into numerical representation. I'm giving that representation to machine learning algorithm. Machine learning algorithm is going to generate again a numbers because it's a mathematical algorithm, right? You know the mathematical algorithm means I'll give some input numbers, I'll get some output. Multiplication, a very simple thing, or vector addition, whatever. If you say mathematical algorithm, even optimization, higher mathematical model, even if you take a kind of a calculus, some input samples you are giving in terms of numbers, you are getting some output numbers, right? Same thing here. But so the model will work only with numbers, right? Now I don't have numbers. The ChatGPT, what you are using, are you passing any numbers? ChatGPT, you are giving a text, right? You are giving a sentence, you are asking ChatGPT a question, right? So how you are relating that, how the ChatGPT will understand that question? ChatGPT is converting your question to this numbers, right? To converting to the numbers, and it's doing some mathematical computation. It will find out a different set of numbers, and from this numbers, this is the ChatGPT models or LLMs are producing responses. We'll call responses the input. We can call it as a query, or you can call it as a prompt, right? So this is what inside the basic thing happening in ChatGPT. The first step, a kind of a pre-processing step, it's converting into numbers, and it's doing some processing. We'll see that what kind of processing it's doing, how it's doing, and it's generating some numbers again. That numbers are converted into responses. So what we are thinking, we are looking it as a kind of a conversation system. If I give some input, I'm getting an output, right? But what is happening is this. Okay, now this is the purpose. This is the purpose of can say that word embedding. Now the question is how to convert this into numbers, right? This is what the first lecture we are going to see about, how we are going to convert this into your numbers. The next lecture, the next session after a break, 7:45 or sometime, we are going to start again. I'm going to talk about the second phase. The second phase in the sense how we are going to convert, or I'll just change my color of the pointer. Yeah, the first lecture I'm going to talk about how we are going to convert to the numbers. Second lecture we are going to see that how LLMs or how ChatGPT is using these numbers or converting the numbers into responses. So this is what the two things we are going to see. Fine. Now I said clearly that why we need representation, right? The one reason is mathematical model. Mathematical model needs numbers, right? Fine. The next one, your input. If you see that your input, it may be a words, your input may be a sentence. To the chat GPT, maybe one word or one sentence or two sentence. Sometimes you are giving a paragraph, right? Now students are what they are doing. They are taking the notes as such. They are giving to the chat GPT model. They want a summarized output. They want to learn, or they don't have time. They are feeling that they don't have time to read the complete text. They want 5-6 lines to understand the concept, right? So the input can be a words or sentence or text. So here, so I have to build a model for not only for a word to numbers, right? So it means that I have to build a models to sentence to numbers as well as a big document to numbers also, right? So this is one step we are talking about a word. The same model can be extended to sentences and your documents, or even multi-documents, multilingual documents. If you give a Hindi, if you give a Punjabi, if you give a Telugu or Malayalam or Kannada, the model should supposed to work, right? This is what the purpose. Now, so okay, so now the next question is, so the numbers you are telling that you want a numbers, right, sir? So I'm giving you words and then you want a numbers. Can I assign some random numbers to that? I can assign instead of, okay, rather than random numbers, I can assign some dictionary number. Definitely the word may be available in a dictionary. I'll take the dictionary ID 77. I can apply this to the 77, 75, or I can apply some random number from the 75. why I want some meaningful number, right? That's the next question. Any answer from participants? Why? The question is, I have multiple ways to convert this word into numbers, right? I can do a random number also. I have a random number generator. The model can give a random set of numbers for the word. Say, for example, I'm saying the word like say Delhi. I'll get a random vector, right? Why? Why I should not go for random vector? Participants, I want answers from your side. Why we cannot go for random vector? Because there are a lot of mechanisms to generate vectors. I'm saying that a simple mechanism is why we need a mathematical algorithm to do that. Can I use some random vectorization technique to convert that into random vector? Participants, any answers?
Participants can raise their hands or they can unmute themselves.
Yeah, thank you, ma'am. Fine. Okay, but you try to participate in the discussion, participant. So I'm just expecting you to participate in the discussion, right? So the talk should not be monotonous. So we'll have a discussion. We all are faculties. I'm also a learner, and you are also a learner. We'll have a discussion, healthy discussion. We'll have. I don't want to just teach you or preach you. So this is a kind of a discussion we'll take it. Okay, please involve in the discussion. Yeah. So Nilesh sir, the question is, I'm telling that you said that the word is converting into numbers, right? Can I use a simple randomization techniques, random algorithms to convert the text into numbers? Why I should not use that randomized technique? Why I need to use some specific algorithm?
Maybe, sir, the keywords, the optimization type of concept can be applied in that.
Okay, fine, sir. No issues. Thanks for your answer. So I'll tell the reason. So the reason why we want, yeah, so why we want some algorithm to generate, the meaning is I want some meaningful representation. I don't want some random representation. The reason is I'm going to find the meaning of this. I'm going to find the meaning of your words, right? I'm going to find the meaning of the sentences. I'm going to find the meaning of the text, because those things are used in your query or a prompt, and I have to generate responses, right? So I need to understand that meaning of the word. That meaning of the word I can understand only from this word representation. It means that I can call that as a effective representation, right? It's not just a random representation. The representation should be effective and meaningful. If it is a meaningful, Delhi, if I'm giving the vector, that numbers are meaningful. If I give the vector for the Punjab, right, and those vectors should be close, or those numbers should be somehow related to Delhi, right? You agree with me or not? And I have something called air pollution I am talking, or air quality I am talking. So these numbers should be somehow related to the Delhi numbers, because you know that Delhi and air pollution may be related word. Delhi and Punjab related word. I'm saying about India Gate, or I'm saying about Qutub Minar, right? So the numbers, whatever I'm having for this Qutub Minar, as well as they say not only the Delhi and the numbers with the India Gate, that should have some similarities. It should have some common nature, right? If it is have the common nature, then I can always say that the representation is a good, effective representation, right? So because how humans are understanding the words, we are understanding the words by its relationship, right? So similar way we are going to build a mathematical model. Okay, so now before word to vec, so this we are talking about the algorithm, as I said, 2013 algorithm. So before that, people used random representation. As I said, that random representation will not convey any semantic nature of the word, right? So before random representation, there is a popular representation called one hot vector. So one hot vector in the sense. So there is something called vocabulary. We used to say that vocabulary. Vocabulary means we can say the unique words or common unique words or dictionary words. So we can call that as unique words or dictionary words. It means that the words in a dictionary, right? So the unique words. What usually we will do in the one-hot representation is we'll take a document, we'll list out all the words in the document, right? From starting from A and an, on like that, and ending with the zoo, like that. We'll align all the documents, and we'll give a numbers to the documents. Remember, these numbers are not word vectors. These numbers are only IDs. A means I'm saying 1, and an means 2. Like that, I'm going to give a number. Zoo is a word, say 15,000 words I'm having. So the zoo is a 15,000 words, something like that, right? So this is not a vector again. This is just a number representation we have created. Now, from this number representation, how we can create a vector? As I said that the single number may not be meaningful, we need a vector. So I know that A is a 1, right? And I have the word Delhi. I have a word Delhi. The word Delhi. The ID for that word Delhi is, example, I'm saying that, say example 79. The total number of words I'm having 15,000 words, right? Now, what is one not representation? One not representation means this Delhi word I have to represent in 15,000 numbers. So remember, 15,000 numbers I'm using to represent the word Delhi. All are zeros except the 79th place. 79th place will be 1. All the remaining portion be 0. This is called, you can see the example, this is called one hot representation. Only one place, one position will be 1, remaining values are 0. It's a very old popular mechanism, right? But the drawback of this mechanism is same. If you say that Delhi, if I say 79 is 1, if I get the vector for say for example Noida, if I get the vector for Noida may be the word in 700 position. That position will be 1. Remaining positions are 0, right? If you compare these two numbers are unique, right? I cannot compare these two numbers. If you want to compare mathematically, if you want to compare two set of numbers, two set of vectors, we can call that as a kind of similarity check. We'll say some multiplication or dot product similarity. If we take the similarity between these two set of numbers, I'll get a 0. The model is telling that, hey, Delhi and Noida is nowhere similar. So that's wrong, right? So we'll see the example. If you see here, this is what the one-not representation, right? The one-not representation, the size, as I said, the vector size is 15,000, right? The 15,000 is the example what I have given. In real time, there is something called pen tree bank corpus. It have 50,000 words. And Google 1T corpus is there. It have 13 million words. So each vector, each word size is 30 million. 30 million big number, right? 30 million numbers will be there to represent a Delhi. In that, only one place will be 1. It's a complete sparse vector, right? So we cannot use the complete sparse vector. The problem is computational cost. And there are a lot of zeros is the one reason. If we take any dot product, if we take the similarity, if we take, say for example, hotel and motel, I know these two are related words. I'm asking the mathematical similarity. The model says that mathematical similarity for these two words are 0. So this is not a, these are the drawback. This is the drawback of this model. So I have to go to the other model, right? So people invented something called latent semantic analysis. So you may hear about the concept called SVD. Participants, again a question. Can anyone quickly say in a one phrase or one sentence answer what is SVD? SVD. You hear the term SVD? What is SVD, participants? Even if you know, if you don't know the answer, please interact with me. I'm getting a feel that I'm talking alone, right? Yeah, no idea, sir. Fine, no problem.
Shall I ask?
No problem, man.
Hello.
Semantic vector, Deepali. Thank you for your answer. Thank you for participating. Any other answers? Okay, so no problem. So this is called singular value decomposition. Is a one popular mathematical techniques. We are technique. We are not. It's a part of something called linear algebra. We are not going into that actually. It's an so I'll just to say what it will do. So as I said that I have a document, and I have a sorry, I have a word. My word is a very big representing the word. I'm representing a very big set of numbers, right? So I can create a matrix. Suppose in your chat GPT, we are not giving a word as an input, right? Are you giving word as an input? You are giving a phrase. If I ask what is machine learning, you may type, right? You are typing in a, nowadays people, we are not using Google search engine, right? How many of you are using Google search engine? So I just have a question to you guys. How many of you using Google search engine?
I think,
Yes,
sir,
sir.
everyone is using.
Everyone
Yes, sir.
is using. Are we searching? Are we using the searching purpose like how we searched 2 years before or 3 years before? In the sense that, are you looking at pages? Are you going to the next page, next page, next page, like that we are going?
No, no, sir.
Thank you, ma'am. Right? We are interested in the AI overview of Google. Am I right?
Yes, sir.
Yes.
Because why we should waste the time? Because that's our intuition. Why we waste the time to go to the multiple pages and search the answers? The Google is collecting all the information. It's going. Google is giving the right information. I mean, I don't know right information or not. It's giving some summarized short information, right? Not only us. So if you see that we are little old generation, if we are also doing the we are doing the same. You think about the new generation. I asked this question, same thing to my class, NLP class. I asked, how many of you using Google searching? Yeah, we said everyone is used. How many of them moved to the second page? I asked. In last 1 week in the Google search engine, how many of you moved to the second page? Only one guy out of 80, only one guy raised the hand. Sir, I moved to the second page. Because
Yeah,
what
most of the people are connected with Gemini only.
correct,
Yeah.
correct, ma'am. Yes, ma'am.
Or they can go
So
to the chat GPT. Yeah.
correct. So if you closely see that the chat GPT is the chat GPT models are reducing the usage of, already we know that there are statistics says that people are not at all going to the Wikipedia, right? So you may aware about Wikipedia, we may aware you may aware Wikipedia. So but our students may not aware nowadays what is Wikipedia. When we are doing the research, how Wikipedia plays a major role. Any concept we will give in a, any topic will give Wikipedia will understand that, right? Now, no. Wikipedia is gone. Next, search engine is going to gone. So as we are not, Google is also watching us, right? As you are not interested in the second page or third page, why I should run my algorithm to show the second page or third page? True, right? So the future will be, there won't be any search engine. The search engine is with us for last, from 1990s. Search engine is with us for last 35 years. So the ChatGPT is going to demolish the search engine. Soon we are going to see that there won't be any search engine, because for each search query, the Google model, so wasting a lot of electricity as well as water. everywhere there is a scarcity, right? So Google is thinking now. So why I should give all the answers? He want I can pass that to a RAG or LLM system, and then I can give only the answer, right? The future is going to be there. Okay, fine. So as I said that when the ChatGPT model, we are giving a sentences. We are not giving a words, right? We are giving a queries. We are giving sentences like, so what is machine learning? Something like that. What is machine learning? So I can say that this is each word. What is machine learning? Each word vector I am having. This is the vector of each word. So set of vectors, right? Set of vectors, we can call this as a matrix. Matrix size also given. SVD is a kind of algorithm. It will take a big matrix and it will decompose that matrix into three relevant and latent matrices. That's the purpose of SVD. SVD is a heavy computational algorithm. So I'll just skip this with this introduction to SVD, and then we'll see our new we'll see the current algorithm what we are talking. We just understand that SVD means if we give any matrices, it will decompose the matrix into three latent matrices. Okay, so there are problems, so we'll just see that. Now we are coming back to the word embedding, right? In word embedding, the people are using some important semantic lemma. We used to say that the semantic lemma. So it's called distributional semantics. So this is a sentence coined. This phrase is coined by the famous linguist J.R. Firth in 1957. His statement: "You shall know a word by the company it keeps." I want participants to explain me this sentence. You shall know a word by the company it keeps. What is the meaning of this sentence?
I think, sir, if some word is there,
Okay,
then
sir.
company means the signature of the word, that semantics, that self-explanation should be there.
Okay. Any other answers? Thank you, Nilesh sir. Thanks for your answer, first of all. Any other answers?
Maybe it is related to the brand value or the reputation created by that particular organization for that particular word by. Uh,
Okay. Thank
okay.
you, ma'am. Here, the company is not related to organization or that brand. Companion,
Maybe
the
it is the
company here.
context.
Yeah,
So it is the
right,
context in
right
which it
answer.
is. Yeah, it is the context in which it is referred
Yeah.
to. Yeah.
Thank you, Anuj. So thank you, Mamta ma'am, and for your answer. So Anuj said that context. Company means context here.
This is
Any
Dr.
other answers?
Shastri. Yeah, yeah,
Sastri sir, yes sir.
yeah. So this was the context. I mean, I just said this is the context in which you
Oh,
are
okay,
referring
okay.
to,
The
right?
answer is from okay. I thought it's from Anuj. Yeah, thank you, Sastri sir. Okay.
Yeah.
Any other answers? Explanation for this? Fine, no problem. Yeah, thank you. So here, as sir said that, so this is a context. The company here, it says context. You shall know means you can understand the word by the context. It means if I'm giving a sentence, and if I'm giving a sentence and then I'm using a word, something, I'm just keeping x, still you can understand this word based on the context. All right. Sometimes if you see that when we are going somewhere and when we are reading something on driving, while driving, we can see only a part of information. Still our brain recognizes that what may be the second part, right? Sometimes when you are reading the old books or papers, some sentences, some words may not be visible. Still your brain says that, hey, this may be this correct word, right? It's a kind of a
No,
filling the blanks.
so it's like that, like the mouse. It may be an animal for one person, for in the other context, when we are talking about the computer, it's a mouse for our computer system.
Yes, ma'am.
Yeah.
So
So
that
this
is
is
a
one
different
point.
concept that is called ambiguity, ma'am. So I'll explain this concept once again with the example. You will understand this, right? I'll explain this again. So I can understand the word by the company it gives. Okay, I'll do one thing. I'll directly go to one example, right? As ma'am asked that. Okay, now this is one exercise to all of us. I blurred some word here, right? This is not a computer vision or image process, image related talk. It's LLM related talk. Purposefully, I blurred some word, right? I want you to find out what is the word. It's only one word. Wherever I'm seeing the word in this search, I blur. Participants? So if you are taking more time to identify the word, it means that we are aged. If you feel that you are young, I want result as early as possible. We'll see that who is young in our group.
First one, sir, I think have.
Have, HAV is a. Okay.
Yes, sir.
I just post your answer, have. We'll see that any other answers. I blurred some word. I want what is the word.
It may be I love my mother.
Okay, ma'am said it's a love. So love is the correct answer. Yeah, thank you. Thank you, ma'am. So how ma'am knows that it's a love?
Sir, as it is written interpersonal affection and pleasure, so I relate it with that ki love my mother.
So that is called company, ma'am. Now whatever I have given is a company to you, context to you. You identified that word, right? Even I'm not showing the word. You have the knowledge about these words. You have the knowledge about English. So you identify, right? Whatever I have given here is a context. And what you identified is a word, right? Is it clear? Now, the similar exercise we are going to give to the machine. I know the word love already. I blurred because I only blurred, right? Similarly, I'm going to hide or I'm going to mask some word and I'm going to give the sentence to the machine. So as I masked the word, I'm asking a machine, hey, or algorithm, I masked some word to try to find out what is that word. Because that is a machine learning or AI algorithm. AI algorithm will put different words, it will do the processing, and it, as sir first sir said about have, right? Like that, first it will check, it will ask me, hey, are you saying have? Then I'll say, no, it's not a have. But as it is a machine learning algorithm, it don't want to know, it wants some numbers. It wants some numbers in terms of errors. So it's asking, it will ask me that, okay, you are saying have is not a word, fine, but you tell me that how close I am. It means that what is that closeness between the have and then love? I'll say that, hey, this is have and love are not near. This is too far. You are not very near to the answer. So I'm telling the machine that your error is high. Okay, the machine will go back. Machine will do some parameters. It will come back, and then machine may say that, hey, are you telling something like also something later to here, right? And I'm checking that. No, like is not answer because what word I'm having is a love, right? Now I'm telling that, hey, like is not answer, but your error is minimum because like and love, you know that some are associated or nearby words, right? It's a close verse, like and love compared to have. I'm telling that, hey, now the answer is wrong, but you are close to the answer. Now the model will again go back, machine learning model. And machine learning model will fine tune. We used to say something called, I'm not using any machine learning parameter, machine learning jargons. The machine learning will fine tune, that's called fine tuning. Machine learning will again keep on learning, changing its parameters or numbers. It will come back, it will say that, are you saying love? Now I will verify, I'll check my word, yes, love, and you are also telling love. The error, the difference is zero. It means that the error is zero. I'll tell that, hey, no error, you identified right. Then the model will say that, okay, whatever I learned now, that I'll store it, right? Whatever the model learned, because whenever I'm giving the output, whenever I'm saying that this is wrong, the model is tuning something. It's changing some numbers to get the word love, right? Then model is saying that, okay, whatever the things I have changed, that I'll keep it as such, right? So this is called the machine learning concept. We used to call this as a kind of back propagation, right? So you don't worry about that, the machine learning concept or not. You simply understand that how we two interacted, how we identify this answer similarly. So the machine will understand this, right? Is it clear? I'll give a 30 seconds time for you guys to recall what I said. If you have any questions, you come back. 30 seconds. I'll wait. I'll be here. I'm not going anywhere. I'll be here. 30 seconds. We keep calm. Try to brush up. Try to understand what I said. Right? Now, any doubts? I hope you really spend 30 seconds. Very useful. Any doubts? Yeah, thank you, Bharati. Thank you, Mamta ma'am and Nilesh sir. Others also, please be interactive. Fine. Can we go further? Right. I hope you have understood that. Now, I'm going back to the algorithm. Now, I explained with the example. Now, I'm going back to the algorithm. So, now we have done something, some processing we have done that. So, it's like a human to human process, right? So, as I said that, I have given some example to you, how the machine is working, we have seen, fine. This algorithm is called word to word algorithm. Whatever we human did, they did that. Same thing machine is going to do that. Machine is having a two type of algorithm. One is called SIBO algorithm. The other one is called skip-gram algorithm. SIBO in the sense, see, continuous, it's called continuous bag of words model. So where the context as an input. The model need context as an input, and then the model need output should be word. Context means nothing but set of words. You consider it's a set of words or nearby words. Skipgram is a reverse of it. Skipgram need word as an input to the model, and the skipgram will, the output of the skipgram, the skipgram should identify the context. The skipgram need to identify context. All right. These are the two algorithms. This is a very popular algorithm in word embedding technique. What we are doing is a word to word. This changed the entire NLP thing. Still, this algorithm is popular. Whatever the current ChatGPT model we are using, so the embedding technique, that is a very base to the ChatGPT. The embedding is extension of this word to word. People are derived over the period of year, and then they come up with a new kind of model. But the base is same. The context, word, everything is same. Right? So now, how this is going to different from the previous algorithm? One is it's a low dimensional algorithm, low dimensional vector. We are going to get the low dimensional vector. The earlier one, our vector size, our numerical vectors is very big, but here I'm saying that I don't want a very big number for the word Delhi. I don't have a machine to process that. You give only 300 numbers for Delhi. And I'm going to say one more thing. Don't give zeros, lot of zeros. I want a dense vector. I don't want a sparse vector. So the model is going to give a numbers. Everywhere the model is going to give a numbers. But each word, say as I said that the word Delhi, each word is going to represent with a 300 size vectors. So we are calling it a low dimensional vector. Right? Now, as I said that when I converting into the vector, the advantage is the vector similarity is equal to word similarity. right? So the mathematical the mathematically, if you calculate a two number, how the two numbers are similar. If I give a single dimension number, say for example, 5 and 6 are similar, you will say. Similar in the sense it's very close in that order. At the same time, 5 and then 19, 97 may not be similar or may not the same group. This you can say that, yeah, how you are saying that is a difference, right? This is a single number. Like that, I can say in the vector also. I'll take a two-dimensional. So suppose I have a number 1, 2, and I have a number 1, 1, minus 1. So before that, we have seen a single number. Now I'm just taking two numbers. So 1, 2 will be like a 1, 2. Here that particular first one, 1, 2 vector. Second one, 1, minus 1. 1, 2, right? Yeah, 1, 1, minus 1 is going to be here. And I'm going to have a one more number called, say, similar thing, like I'll take a 5, 1997. 5 times 1997 times the y side, then the vector or the number somewhere here. If I ask you that, which is closer, this is like a, say for example, this is like a Noida, this is like a Gurgaon, right? And this is like a, I can say this is like a Simla. So I'm always say that Noida and Gurgaon are closer compared to that Simla. That's a vector distance, right? How we will calculate the distance? We can calculate the distance physically. This is like a Euclidean vector. We say the mathematically will say that the vector similarity or the dot product. Similar thing we are going to do here. So if the word is near to each other, I'm going to say that yes, these words are closer. So what I want finally after word to word is, finally what I want is, suppose I have the word boy. If I'm representing the word boy here somewhere, and I want a word girl also near to that, right? At the same time, if you give the word, say for example, if you give the word a place name, we'll take, if you take the word Gauhati, I don't want the Gauhati word to be near to this boy or girl. That's nowhere related to boy or girl. I want a Gauhati word to be somewhere else, right? This kind of representation I want. That's my purpose, the word to word, because I'm telling that I'm going to give a efficient vector to you, right? You may ask me that, sir, how we know that vectors are correct? How we know that vectors are really effective representation? We have a mechanism. The next what we are going to see is that. Fine. So the advantage of the word to vector, we'll see the two algorithms I said, right? Again, I'm come back to the algorithm, SIBO algorithm and skipgram algorithm. So you remember these two algorithms. SIBO means input is a context and output is a word. Skipgram, this SG is a skipgram, is word is the input and context is the output. It means, suppose I have 5 words. Suppose I have a 5 words. So I have a sentence like, I saw a cat. Okay, for I saw a cat, and then the sentence end. So here, this I can call that, if I remove the word if I mask the word cat, I can call cat is my output. I remove the word, I put a dash here, right? So this part is called context, and this part is called a word, right? If I give a context to the model, and if I ask a model to identify the word, that is called SIBO. I'll write a different color. The process is called SIBO. The reverse, if I give the word cat and I'm asking model, hey, I'm giving the word cat, you find out I saw a dash, that is called skipgram, right? So you remember the two algorithms we have seen. Fine. So why the word to vec is popular? Why still we are talking about a word to vec algorithm? The reason is, it's not a count based model, it's a prediction. I said the machine learning, it's a machine learning, first machine learning based model. It's not based on how many times the word occurs. It won't take the number of times the word occurs. All right, it's a prediction. Other advantage, important thing. Once the models are trained, once I get this set of numbers, I can use the numbers. I can reuse the numbers for any purpose. If I get the numbers, that's it. I can use the numbers for any purpose, in the sense I can use the numbers for question answering. I can use the same number for building a summarization system. I can use any NLP application, right? Including large language model. Once it's a train, the numbers only I want. I can use that numbers anywhere. Okay. Now, you remember this example, right? And I said two algorithms. One, I said SIBO. What is the second algorithm? Skipgram, right? Now the question to the participants. We have done some exercise, right? Is it belong to SIBO or is it belong to Skipgram? We have done exercise. I masked the word. I asked you to find that. You found, exactly ma'am found the word, right? But I want to know that, is it an example for SIBO or Skipgram? Participants, I guess question is clear.
I think it has to be skip grab.
Sir, Sastry sir.
Yeah. So we are trying to find the word. We are trying to find the word given the context, right?
Yeah. So you are telling SIBO, sir. Okay. Thank
Yeah.
you, sir. Any other answers, participants? Fine. As sir said that it's the what we have done is a SIBO, because I have given a context to you. I asked you to identify the single word, right? So that's an example of SIBO. So one experiment we have done. So how much time we took to solve this one? Sir said have and ma'am suddenly said love, right? We took only 2 minutes to identify that word. Fine, very good. If I do the reverse of this experiment, reverse of the experiment means I don't have that slide actually. Suppose I'm going to have only the love word. I'm going to give only the love word. Whatever the word I mask, I'm going to give that word to you, the word love to you. I want you to fill all the words. That's called a skipgram, right? I'm giving you one single word. I'm asking you to fill the context. Is it possible for a human to fill that? How much time will it take to fill?
Well, it's not possible.
Yes. The reason is why we are going to the AI or why we are going for machine learning algorithm. Certain problem human cannot solve. We used to say something called the NP complete or NP complex problem. Same thing. We cannot fill this. As it is a one word, we tried, we did some experiment and then we finished. The reverse one, we need a month to complete for this one particular slide. If you say the word refers to a variety, I have to check each word. I have to say that what is your error. You are close to the first word or second word. I have to tell that. Then you have to say the second word. It will be a very big exercise, right? So definitely we cannot do that. So that's the reason we need AI model. So we need a mathematical. So that's what we are saying, that the mathematical models are powerful in doing that. If you see that the SIBO and the skipgram is very same. If you are giving a one word in a both side, one word means, say for example, if I have a one word in a context and the word, if I have the one word in the in a word, input is a one word, output is a one word. Both are same, but it's a repetitive experiment, right? We might have studied in our schools why we need a computer. Our brain will be tired when we do the same experiment for 1 lakh times. So I'll give another example. I know that you are good in multiplying two numbers. I'm asking, you know the multiplication or not? Yes, I know multiplication. Right. I'm giving 12 into 24. Yeah, you are calculating and then I'm giving some 50,000 numbers into 50,000 numbers. So you said multiplication, right? Why you are not doing? Because you see that the amount of a job, the amount of the work, multiplication is a concept. It's same. But as the numbers are big, and then it may take a huge amount of time, and our brain may get tired, and we made lot of chances for us to do the mistake, right? That's the reason we have the AI model. AI is very good in doing the repetitive tasks, which a human cannot, particularly the current generation people. They don't want to do the repetitive tasks. They don't want to do the repeat. If you see the whatever the last class you are taken, that if you usually when we are studying, so you may recall that if a faculty summarize that what last class it happened, we may be interested to see that. Oh, right. It's like it's a brush up for us. The current generation is not interested. They don't want to hear repeated second time also. They don't want to hear, right? So that's the reason AI is occupying the current generation people very much, because AI is good in doing that. Fine. So this is the difference between the two algorithms, SIBO and skipgram, right? Now we are coming to the goal of word to work model. All right. Now, as I said that I have done the word to work process. I completed the word to work. I have given a huge amount of text, and then I generated the output. Fine. I'll show the demo also at someone. Okay. At the end, I'll show the demo of this word to work. Now you see that I have generated the vector of 300 dimension vector, right? Now you are asking me that, sir, how you know that the 300 dimension numbers are correct? I have to, I supposed to prove you that, right? Fine. I'll prove that. So this 300 dimension number, as it's the 300 dimension, we cannot visualize the 300 dimension. As human can see only 3 dimension, right? And this slide is only 2 dimension. So I converted this 300 dimension into 2 dimension. The reason is I want to show, I want to you to visualize the world, right? After converting the 300 dimension to 2 dimension, I have plotted here. 2 dimension in the sense, say for example, the word dad is zero point 0.4 and 0.1. So I just plotted the word here. Like that. The word kid, if you take, it's a 0.81, comma 0.41. So the kid is placed here, right? Okay. The now the task to you is what is your inference from this output? This output. I have taken some, I have selected some 20 words, 20, 30 words I selected, and then I plotted. Now I want you to say that, is there any inference from this output? Participants, I think question is clear, right? Question is clear, right? Mamta ma'am, question is clear, or you want me to?
Yes, sir, it is clear.
Okay, thank you, ma'am. So I have taken the words, 30 words, 30 words I selected, I plotted in a 2 dimensional graph. Now I ask you to find with your eyes what is the inference from this output. Is there any inference? Inference in the sense, can I say, can I group some words? Can I group some genders? I said no. The word Gauhati may be in a different place, and the word boy and girl will be in different place. Are we finding some things are like that here? Role, yeah, Ekta ma'am answered. Thank you, ma'am. Role, women or men can play. Okay. Any other inferences? Okay.
Daughter,
No.
grandmother, aunt, father, sister.
Yeah, ma'am. Sorry, ma'am. Your voice is someone talking or not? Yeah, Archana, ma'am. I guess
Yes.
your voice is not audible, ma'am. Can you repeat, please?
So of daughter, grandmother, aunt, father, sister, son, brother, cousin, uncle, grandfather.
You are telling something like still, I don't know whether it's from my side the problem or Mamta ma'am, can you hear her voice?
Sir, actually, voice is not so clear. Ma'am, you can write on the chat box also.
Yeah, please. Yeah, Mamta ma'am said that office staff and family members. Yeah, you ma'am is telling that we can divide this into two groups. One is a family, grandfather, grandmother, daughter. Other one is
Yes.
yeah, staff, director, manager. Yeah, good observation. Anything
Sir,
else? Yes, ma'am. Now
sir,
it's
you
loud.
got me.
Yeah, Archana ma'am, please continue.
Yeah, this is what I wanted to tell, sir, that it is showing the relation of
Yeah,
daughter, grandmother, aunt, father, sister, son.
is it right?
Yes.
So what you tried is the two clusters you said. So I just added two more clusters. The one word is about the family members, daughter, grandfather, grandmother, brother, uncle, aunt, cousin, something. I have one more thing like blue and pink. Colors are also in a somewhere close. And the
Okay.
director, staff, manager, boss, person, owner, related to some projects or some company. It's one side. The words related to a project, notion, concept, idea, innovation, something like that. So you see that you asked me that how you are telling that these numbers are powerful, right? Now we have a proof to say that this is a one kind of proof to show you that the word whatever we have, the numbers whatever we generated, those numbers are meaningful numbers, right? Okay.
Yes, if
Now,
we know the context only, then we can relate these cluster of words.
yes, ma'am.
We know
So
the
the
context.
here it's only we are talking about the word, but we are given an input to the model is a sentences we are given. That's a context from the context. Model understood that and then it's giving. But here on the single words. Now, one more important inference. Okay. Okay, fine. Yeah. I'll go back to this slide. One more important inference is there. So you know about vectors, right? All of you know about vectors, mathematical vectors. What is vectors? Vectors have two things. One we'll say magnitude, and what is the other one? Direction, right? Vector means magnitude and direction. Magnitude talks about the numerical values. Direction talks about the direction of the vector, where the vector is going, something like that. So say for example, if I say this is a vector, the distance is a magnitude, the direction is where the vector is going. This is the other vector, the distance, right? So whatever you said, the clustering is, this talks about the distance. So far what we say is a distance. The distance is very small between the words. So you said that you said that you have grouped the words or clustered the words. Can we say any other inference with respect to direction? So here, one more inference is there with respect to direction. I'll show that, no problem. That's a little difficult to identify. I'll put the direction in the sense this is our direction. Man and women are in this particular slanting line. Dad and mom, right? Grandmother, grandfather. Don't worry about the size of the line. You just see that slanting line, how much slanting it is. Sister and brother, aunt and uncle, daughter and son, father, mother, right? I have given a clue. Now you need to explain me that what is the inference. Dad, mom. What is the common between all the word I said? Dad, mom, man, women. aunt, uncle, grandmother, grandfather, daughter, son, father, mother, sister,
Gender.
gender, right? So I'm saying that the word to vec is not only capturing the close related words, it captured the information of this gender also in this direction. This is a direction. The model is telling that, hey, if I say some word here, I'm saying that I have given a word one here, and this is here word one, and then the word to vec is telling that if this is a male gender and this is a female, this is a masculine, this is a female, right? But you remember one thing, we are not giving any information to the word to. We are only giving the sentences, raw sentences, your queries, right? Whatever queries in India, whole the whole, whatever the queries ChatGPT we are given, the queries if you take and if you train the model, we get the kind of similarity. This needs only the sentences, meaningful sentences. It's not in like a other image processing or image annotation where we need images with we have to say that what object that image is there. No, you give a meaningful sentence, the model will give this inferences. This is only few inferences we have. There are a lot of inferences. We'll see that. Okay. Before that, I already explained about the models here, SIBO model, right, and the skipgram model. So I already explained that. So the diagram says about, you can see here that this is a context C and this is a word, and this is a word and this is a context. So context to word means which model? SIBO model, right? Context is the input, word is output. Skipgram means word is input, word is a single word is input, context, multiple words are output. You always remember our love example where I have given I have given to you. To you means your brain. We have given information that lot of words are given as input, and I ask you only one word as output. You tell me what is the word I mosque. It's a SIBO. Skipgram. It's a reverse of it. I'm giving the word only love. I am asking you to fill all the remaining words. We know which is not possible. That's called skipgram. I'll just skip this mathematics behind that. I already explained that, right? The mathematics, how it's asking the error and all those things. That's what it's explained here. It's very easy.
Excuse me, sir.
Yes, ma'am. Yes, sir.
Sir, please go backslide, sir.
Sir, you want me to go back to some slide?
Yeah, previous slide, sir.
Yes, sir. This one?
Yes, sir.
Yeah.
One just query raised in my mind, sir.
Yeah, please.
There are two models, SIBO and SG model.
Yes.
Say, sir, from various contexts, we derive some word or word derived from that.
Yes.
And similarly,
Yeah.
in another scenario, the word after getting the inputting the word, various contexts may be obtained. So,
Yes.
sir, if the same question we will take from the context to word, and again the same scenario, the output of that word will be inputted into the schemegram.
Yeah.
The context is the all the contexts may variates or much more context may be generated. It's not like LHS RHS proof.
Yeah. Understood. Yeah.
Vice versa is, I think, not true, sir, because
Yeah.
some more features may be obtained from that word, from that scenario.
Yes. So this is a very base model, sir, where we started with the word. Now the current model is taking a 512 context size as an input. In this word to vec model, the context size, maximum context size people are using is only 5. It means 5 words only I'll take. If you see here that this is a 5 context, window size we'll say it's a 5. Left 2 words, right 2 words. But now the current LLMs are using 512. The context is very big because I have to. The reason is we are not going for the word level model now. We are building a sentence level model. Your input to the all
Okay.
LLM is now sentences.
Okay, this is a very basic one, so that a less
Yes,
number of
that's what that is
context
a word
will
level. Yes,
word.
correct.
Exactly, sir. Thank you,
The
sir. Thank
concept
you.
is the concept from here is derived to the sentence level model.
Okay, sir. Okay.
Yeah. Okay.
Yes,
Thank
sir.
you. Yeah.
Thank you, sir.
Thank you. So this is a, that whatever I explained, that single context, multi-context, those things are there. I'll just skip gram. I already explained that. We'll just see one example of mathematically. We just to see. I'll take one example and then I'll just to see that. So you remember that when I said that have, like, love, the words during the how we identify the word love, I said about the error, right? So some error will be calculated, the error will be read. I'll say that have, if you give that, I'll say the error is more. Then I'll say like, if you give, I'll say error is less. Love, if you give that, I'll say the error is 0, right? The same thing. How the mathematical. So if you see that, I've taken a 5 words. The cat sat on floor. I'm masking the word sat. It means that you remember, I know the word sat. Purposefully, I am asking the model in this 5 word. I'll give 4 words to you. You find out what is the middle word. So you remember again, the algorithm already knows the word sat. It means that till I get a word sat, I am going to train the model, right? Train the model means the model may have some numbers. I'm going to get that exact. I'm going to fine tune the numbers. I'm going to change the numbers to make sure that I'm getting the word sat. So this is the mathematical things. If you see here, yeah. But here the one point I want to explain here about the error part. So the remaining thing maybe little more mathematics things or the multiplication and the matrix things and all. So you no need to worry about that. How you understand that how the machine is understanding taking the word, the initial one not representation, and this is the vector. This is the word vector. This is the output of our entire system. What we are talking. This is the output. So this vector will be here. This word vector will be here. This matrix will be here. And I have a word here. So word 1. The word 1 will be multiplied with this vector, and I'll get some intermediate vector. I can call the hidden layer, or we can call it as a vector v. From this intermediate vector, I'm going to get the output vector. Again, output vector also in the same dimension, where the output vector says that one the particular place will be 1. It means that the word, say for example, the word sat. This is the position of the word sat. This is the position of the word cat. Right? This is the position of the word on. So only the first, that particular position will be 1 first. Remaining values are 0. So this 1, if you say that it's the second position, I'm getting the second vector here. So it's a set of vector. Initially, we are keeping a random vector. Slowly, we are asking a model to find best numbers, right? So these best numbers, this matrix representation, we are calling it as word vector or word embedding representation. This is the final output of our algorithm. Finally, we'll get a matrix like this for all words in your corpus. I said the word A, right? So this is for word A. This is for the word and, like that the word up to zoo. I'll get this vector. So the corresponding, this is, I'm calling this as a word vector for the word A. So this is the fourth word. Say for example, this is the word on. Here the word on is the fourth position. So I'm saying this is a vector for the word on. So this is the final matrix, mathematical matrix I am learning, right? So in between, I'm using some machine learning model, machine learning classifications like softmax. Whether you heard about this softmax? No problem. So I'll say, so you when you are doing this computation, right? Finally, you'll get some score like -5, like a 0.2 point. This is a mathematical calculation, right? You'll get some score like this. So -174 plus 76, some numbers will get. I cannot decide from this that which word you are talking, because you are telling that this is the output. But what I am expecting is, hey, I have given a word cat, I have given a word on. I want to know that whether this is a sat or not. You are giving this numbers like this. How I know that this is a number of sat, number to related to sat? I cannot, because I don't have a number to the sat. Now, this score is given to the softmax. What the softmax will do is, softmax is a probability function. You know, probability means it's a that the total values should be, total sum should be 1, right? Each word it will take, it will convert into probability values according to the level in this particular vector. Say for example here, 76 is a major contributor, say for example. So I'll get a maximum probability 0.7 for this. The remaining values, probability value may be 0.1 to somewhere, 0.1 somewhere, 0.1 somewhere. All remaining values will be 0. Right? This is the output of softmax. If you see the total probability is 1. So I'm saying that, hey, here this is the maximum 1. You need to focus. Now, this can be converted into a kind of one-hot representation again, where whichever is maximum here, you keep 1. All remaining words you keep 0. Right? Now I'm telling that the last word is, I know the last word is zoo. I'm telling that, hey, your answer is, you are talking the cat and on, I have given that, you are telling that the answer is zoo. No, I'm telling that I know the word sat. It means that I want this particular sat. This is the position of the word sat, right? This position to be maximized. But you are telling the last word zoo is, you are telling that zoo, this output is a zoo. I'm telling that, no. I'm not happy with this. This is wrong. So now I'm calculating the error. You see that? So as I said that this is the probability values, right? I'm calculating the error. I'll show that. Okay. Yeah. So here I'm calculating the error, how close the y and the y sat is. I'm subtracting these two and then I'm calculating the error. With the error, I'm going to modify these numbers. When errors are 0, then I'm stop modifying these numbers. Then I'm just keeping the number as such. Say, I'll give a simple example. This is, we used to say it's a machine learning fine tuning. I don't know, you know about the machine learning fine tuning and then parameters and all or not. So I'll just put in a very simple example, layman example. Suppose you are zooming and you want to take a photo. You are sitting in your home and then you are just seeing a bird outside. You want to take a photo. You have a good lens camera. You are just taking and then taking a photo. You cannot take a camera and then you cannot click as such, right? Because the bird is, say for example, bird is 50 meters away, right? What you do, you'll adjust the lens, right? So you adjust the lens until you get the clear picture of that bird. Once you get the clear picture, you will click it, right? Same thing. When you are adjusting that, it means that what you are doing, you are adjusting the lens, right? You don't know what number is a perfect number initially. Initially, you are taking a random number in the sense whatever earlier the thing you lens the adjustment used to that, you are just fixing the same adjustment. You are seeing that you are not happy because the figure is not clear. So you are adjusting. You are doing plus, you are doing minus, slightly we are adjusting. We are coming to one number that where the bird figure is clear, and you are clicking the picture. That's called fine tuning, right? The earlier lens value, maybe say example, I'm saying 0.7 is the default, randomly the value, but actually I'll get a clear picture of the bird in the lens of say 0.17. So you are adjusting still to get the 0.17. Once you get the 0.17, you are clicking the picture. Similar thing I'm doing here. I started with a random number 0.7 something. I just want the error. How am you are saying that that particular bird picture is correct? If you see, if you're keeping here somewhere in a point two somewhere, you are not getting the clear bird picture. It means that you know the original picture. Your brain knows the original picture. The brain sees some picture and then brain is telling that, hey, there is some distortion or there is an error. So I want more. I want a good number. You are moving to the good number. Now in one particular point you are just stopping. Yeah. Now whatever my brain says that, yeah, this is a clear picture. It means that your brain already have this image of the bird. Whatever you are seeing now, your eye is seeing and then your brain is seeing. Now these two are compared. These two are similar. It means that the error is 0. So you are just fixing. Okay, you are taking a hand from your lens and then you are going to click the picture, right? Same thing we are doing. Yeah, we are fine tuning the numbers. different numbers may be there. The model may start with some different numbers. Finally we are coming with to the one good number for that particular word. So in lens case, it will be one number, but in a real time, in the word to work model, there will be there are multiple numbers. So we need a mathematical algorithms to get that one best numbers, right? Fine. Okay. So I think can I take a 15 more minutes and then can I give a break, ma'am? Is it fine?
Sir, as you wish. I
Yeah,
think we can continue, and after that we can go for a break if you
correct.
want.
Go with this flow. Once I just finishes the word numbering, then I'll give a break, and after break we'll start again. Participants are okay with that, I guess. Okay, fine. Okay, now, as I said that, I've given one small example for the power of word numbering. What are the other things? This we discussed already, the direction, dad, mom, and other things. What are the other similarities? See here, I have taken a word Sweden, word in Sweden. I have taken the vector, mathematical vector of Sweden, right? And I have taken the mathematical vector of Norway, and I have compared it, and I got this distance. If you see here that geographically Sweden is close to Norway, I'm getting a mathematically also I'm getting the same kind of a high distance. It may I mean a high similarity values, right? See for example, Netherlands also, but Netherlands is little far from Sweden, so I'm getting a less similar value, little bit less compared to the Norway. Slovenia is completely away from, say, compared to Denmark or Finland, it's completely away from Sweden, and I'm getting the different scores, right? This is the one example. So, capital and country. So, this direction, you know that you remember that one, you said that this direction is gender. Now, that one more inference from the direction. If this is a direction, then it says that country and capital. China is in real in after mapping this, China is here and then Beijing is here. You see that direction. France is there, Paris is here. Germany, Berlin. Portugal is there, Lisbon is there. Obviously, if I have the India here, I don't know what is India's capital, right? But I'm seeing some Indian city here. Then I can always take a decision, strong decision that, hey, I know that this city is the capital of India. All right, because the direction says, all other direction says about a capital. Then obviously here we'll have a New Delhi. So that will talks about, that will matches that country and capital. This is again inference from word to word. So one more vector inference, if you see that. So I can take a king mathematical vector, right? From that I can remove, minus means I can subtract the man. So you just think from king, I'm subtracting a man. After subtracting the man, I'm adding women, vector of women, numbers of women. And the vector, whatever the output vector, whatever I'm going to get, that will be approximately equal to the word queen, right? So king, from the king you are subtracting man, and you are adding women vector to that. So the output vector should be approximately equal to the vector queen, right? So, or you can say in other way also. So queen, you can take, you can take a queen vector, you can subtract from the queen vector, you can subtract the women, and you can add man vector to that, and the output should be close to king vector, right? So this kind of regularities also you can get it from the as output of word to word, right? Now, so far we have seen example with respect to single language, right? I talk only about English. How if I do the same thing for Hindi and Punjabi? I don't have an answer for that actually, but I have only the answer for in respect to the other two other languages. We'll see. Spanish we have. So This is a two different languages. If you see that, I have a word for in English. Similarly, I have the word for here. Right? Word 5 is here. Word 3 is little down to 5, 3. But the numbers, the values are different because two different languages. One is completely away from these numbers. Here also, you can see the one is completely away from this number. I have both horse and then cow. Horse and cow are close. Pig is little bit near to cow. Pig also near to cow here. And dog is somewhere little bit away. Dog is away. Cat is completely away. Cat is completely away. Right? So the point here is the model is not only good in understanding a single language, it's very good in understanding multiple languages. At the same time, the position of the words have some similarity in multiple languages, right? The always, if you train similar languages, these two languages are similar, so it may be the reason. You know, the Punjabi and Hindi as a nearby states, there will be a lot of similarity. There will be a lot of borrowing words towards that. So if we do that for Punjabi and Hindi also, it will get a kind of a similar representation. Yeah. Now one step further, we are just moving now. So we are going to see. We talked about word embedding. So now I'm going to see that how can we extend it to paragraph or sentences or documents, right? So this is an example for that, how the paragraph, you can see that I can take all three words. What paragraph vector they will do is, if I have only three words, they will introduce one word, one reserved word, they will call it as a paragraph. So while learning these vectors, vector 1, vector 2, this is a vector for a sat, vector for a cat, vector for the, I'm going to learn this vector for this join numbers also. All right. So it means that this is the vector is this, finally this is the vector, this particular vector is our word vector or sentence vector. Sorry, this is not word vector, this is sentence vector. All right. We are just adding one reserved place in the learning time, and we are calling it as a paragraph vector. This is the one way, right? So the other one is, I can simply take all word vectors, I can concatenate, I can do some small learning mechanism, and then I can generate a paragraph. This is other way. There are two things. So the paragraph or sentence vectors from the word vector, and you are generating the word vector while learning. In your LLM, you are giving a prompt. Each word will be converted into a vector. Finally, each word vectors are putting together, and then they will get a one single vector for your query. Right? So there are multiple ways to combine that. So if you say that the country of my birth, if you're giving input, right? The model will take the vector for the word the and country, and I'll join together, I'll get a one more vector. Of and my, I'll get a one more vector. My and birth, I'll get a one more vector. Like this, I'll just go upon, I'll just build on top of it. Finally, I'm getting the one single vector for this sentence, right? Or query or prompt. So we started with the word embedding. The same word embedding can be extended to query or paragraphs, right? So I'll take a 5 more minutes and then I'll give a break. We'll have a 10 to 15 minutes break, then we'll stop. Yeah, fine. So now we are coming to that LLM. So before going to start with that LLM, so I want to show one small slide. One second. Whether this okay, one second. Okay, we'll do one small exercise and then I'll just 1 second. Then I'll give a break. Yeah. Yeah, whether my slide is visible, participants? So I'm going to give a 15 minutes break. So please listen for this 5 minutes. Is it my slide is visible, ma'am, now?
Yes, sir, it is visible.
I have written something, no, ma'am. So sorry, I have written something. No, any idea what is that? So
TJUINO.
ah,
TJUNO.
yeah, tejuno. So we don't know that, we haven't heard that word, right? So we'll just, so now I'm telling that I'm giving a photo.
So I can assume that this is some soft drink or a
Correct, right?
mocktail.
So you see that.
Yeah.
So the why I'm telling this is the multimodal LLMs, right? The LLMs are good now. The LLMs are not only text-based LLM, right? You can give an image, you can ask the LLM to generate the image, right? The same thing. This is a one context. We are not understanding from the word, but when I give an image, you are understanding the word. This is also a context now. I am not giving the nearby words. I have given the image of the word. Still, you understood it, right? You may not need the context nearby word to understand that. If I give an image also, you can understand. You are not understanding that completely. At least you can say that 50% you can understand. You can say that this is a drink or this is a liquid. So people are drinking. It's not only it because they are just keeping. You are seeing that hand and then putting straw, right? You are seeing that. Fine. Now, so I just have the hypothesis, the context, 4 different contexts. A bottle of dash, wherever the tejuna is there, I just given to you. The bottle of dash is on the table. Dash means a tejuna. Everybody likes tejuna. Don't have tejuna before you drive. We make tejuna out of corn, right? I have given 4 sentences, or I can say 4 contexts with respect to that. So now your understanding about the tejuna is more now, right? Can you say something about tejuna now? Apart from that, whatever I haven't given here, I want you to say something else, different context.
Yeah, now I can assume this is an alcoholic drink. That's why the third C3
Yes,
is
yes.
there.
The word
Yeah,
alcoholic I haven't used. Still, you are saying you are generating a new
yeah.
context.
Yeah. Because of that C3 C3.
Correct. And everybody likes. So you can always say that it's maybe the popular drink, right? So I'm saying I'm
Thank
saying
you.
that the bottle of Tejuna. So you can always say that it's a liquid, popular something, right? So
So,
earlier,
sir, from this we can say the SIBO and Skipgram both are working together.
correct. And not only SIBO Skipgram, I added image also to you. So it's a one step further. It's a multi-model. Not only the text information, we are giving the, I can say that we are giving the image information also, right? Okay. Now it's clear what is mean by context. Earlier, before, you don't know about this word. When I give the 4 context, you can understand that what is the word. You know the meaning of the word now, right? Similarly, we can teach any new word to the machine, right? How because now if you see that we learned one new word out of maybe 60 people, out of 5 people, tomorrow somewhere if you see the tejuno, you can say that, hey, I know this word tejuno. Yeah, this is alcohol. Yeah, this is made of corn. Oh, I hear that it looks good. People used to drink that. So those things and all you will come. Now, slightly one more example, and then I'll just stop. Now, I have one more word, tortilla. Sorry, 1 second. I have one more word, tortilla. So the same 4 context you see, C1, C2. So I'm just going to rate this with a LLM here. That's the reason I'm just taking a sentences and explaining. Please listen. So tortilla I have taken.
So let me show you. Go ahead and go. So if we ask here,
Is it someone asking question or someone is talking?
by 130 kilometers east to reach
Dr. Ratandeep, sir. Dr. Ratandeep.
Okay, thank you, ma'am. Yeah. So Now I'm just taking one more word, tortilla. Tortilla also we don't know. But if you see that tortilla is not present in context one. I'm checking the tortilla corpus. With respect to the context one, tortilla is 0. With respect to context 2, tortilla is there. With respect to context 3, tortilla is 0. With respect to context 4, tortilla is there. Now, I can ask you to differentiate what is tortilla and Tigino.
It means
Right?
tortilla is non-alcoholic.
Correct. That is also made up of corn. Right?
Yeah, right, sir.
But we don't know whether it's a liquid or not. One thing. Because
it's not in a bottle, it's
bottle. Maybe
liquid.
it may be some kind of
Maybe.
dish. Maybe I also don't. I'm just seeing the context. So the point here is you are not only understanding the word, you are from the context, you are understanding the other words also. Machine is also. You see that how machine understand that then boy and girl are similar this way, right? Boy and girl have lot of common context information, right? So the model easily understood that what is the meaning of the word boy and girl. We'll see the similar word, we'll see the same. We know we'll take two unknown words we are taken, we'll take a word wine. So bottle of wine, everybody likes wine. So don't have wine before you drive. And the last one is wrong. Context is 0 here. We make wine out of corn. Wine is not made up of corn.
Sir, excuse me, sir.
Yes, sir.
In this wine one,
Yeah.
I don't think C2 is rightly, uh, digital
It's an example, sir.
given one.
It's not in our Indian context. It may be it's an example. Don't take it light. I mean,
No,
sorry,
sir, but
take it light.
no, sir. Actually, whenever we are categorizing into the tabular form, we
Yeah,
are we are actually relating this in real world also. So
correct.
that is why we have to be very concise in that. I think so, sir. This is my
Yeah, I understand your point. The example what I have taken is from the international newses, international content.
okay,
If
sir.
I
Okay,
agree with
great,
you,
sir.
if I take an
Okay,
Indian context, we'll get a kind of different word. I agree with you.
okay, sir. Not at all. I got that point, sir.
Yeah. Maybe in Indian context, I don't know whether I'm correct or not. People won't say don't have wine before you drive. People may say that that may not be an issue also. I don't know, I guess. You see that one more word is there. There's no word nowhere related to this one. Loud. It's not a liquid, so no. For all context, this is 0. So this is how the machine is learning a word. How we learn the word with the context and how we relate the word with the other words. Even if we give the context information, as you know about the Tigino, you can always say that you can understand the other words. Like, okay, so with this, I'll just okay. Sorry, I've taken more time, I guess. Okay, I'll give a break. Now we'll give a 15 minutes break and then we'll start. I'll start the session on LLM again.
Yeah, it's a 7:50 now, so we can start at 8:05.
Okay, ma'am.
Yes,
No, 8 5.
and all participants are requested to stay connected and joined.
Yeah.
Please
So
don't leave the meeting. Just you can mute yourself and don't leave the meeting.
yeah.
And
So
I hope, sir,
8:55.
I
Yes,
hope
ma'am.
after the break the people will be more interactive.
Okay. Okay. Yeah.
And
So
they will
8.
understand more about the vector and the embedding and the word
Yes.
embedding, magnitude, directions, and all. Very nice
Yeah.
session. I like.
Thank you. Thank you, ma'am.
I can think you can see the in the chat box there are very overwhelming responses.
Okay. Thank
Nice,
you.
sir.
Thank you, ma'am. Yeah.
So we'll
So
meet at 8:05.
yeah.
8:05.
Sure, ma'am. 8 5 will
And
meet. 8 5 to
yeah,
8:55. I'll take last 5 minutes. I'll give for any question answering and then discussion. All right.
sure, sir. Sure, sir.
Okay. Thank you,
Sure.
ma'am. Thank you all.
Participants, please stay connected. Don't leave the session. Thank you. I hope all participants have a nice break. One request to all participants to join with their names only as per your portal name, please. We have also written this in our chat box also, that all the participants need to join with their names only, with the name which they have mentioned in their portal. AICT पोर्टल में जो आपका नाम है उसी से आप लोग ज्वाइन कीजिए प्लीज. थैंक यू.
Yeah. Hello, ma'am. Can we start?
Yes, sir. Welcome back, sir.
Yeah. Yes, ma'am.
And
Sure.
we are discussing about how large language models are working, how Chat GPT is using this by
Oh, great.
yeah, by
I
using
missed you.
embedding and word embedding. So
Oh,
please
great.
continue the
Yeah,
session. And
sure.
for concluding remarks, I also welcome Dr. Shipra ma'am. She is also here. She is
Okay.
the co-host of this session, so she will
Okay.
give the concluding remarks. Yes, sir.
Yeah.
Please
No
start.
problem. No
Yes.
problem. Yeah. So welcome back, participants. I hope you enjoyed, and then very thanks for many thanks to actively participating. Actually, I know that how you will be tired at the time of 8 with the family commitment and children, all those things. Still, I mean, most of you guys are listening actively. Thank you, and then interacting with me. Fine. So I'm just going to take another 45 to 50 minutes, and then I'll just explain that. Um, the we are moving to that Gen A and then the concepts. So I missed this slide, so I just added that. Right. So where I am from. If you see that our institute is here. So Bangalore, you can see the Bangalore is here, right? So we are left side straight to the Bangalore. The Bangalore is a place. So our institute is away 15 kilometers away from Bangalore. Fine. So this is a 65-year-old institute. So the top, um, um, the second top NIT in India. Okay, I'll just skip. Fine. Now, so far we talked about what is word embedding, right? So I'll just we have seen that how the important this is in LLM, right? Now we are just moving to that directly to the LLM. So when you say LLM, the LLM means large language model, right? So large language model is LLM. Before that, I'm going to say what is language model. We'll see that, and whatever we have seen the word embedding, so that is called neural language model. We missed that word. We missed to starting from the language model. I'll tell, no problem. So we already covered that large neural language models. Whatever we have seen that word embedding is a part of neural language model, neural network based language model. So we are calling neural language model. Slowly we'll move into that architecture. I'm not going to too technical things. So I'll explain in a layman perspective how we can understand the mechanism of how large language models are understanding your queries and generating the responses. We'll see that, and we'll see some other applications, and we'll see how we can apply this LLM to the other problems also. Fine. Okay, so first question is language model, right? Language model is not a new term. So language model term is introduced in 1950s. You see that when computers introduced in 1948, right? So in 50s itself, people understood that there is something called modeling and then language models, right? So what the language models will do here, the model in the sense here, it's a prototype, right? The language prototype. It means that it's going to kind of, I can say that the language prototype, right? Or I'll just put other terms. Fine. So in machine learning, we used to say something called machine learning model, right? You know what is machine learning, right? The machine learning in the sense I'm giving data to the machine learning algorithm. Machine learning algorithm going to learn from the data, and machine learning algorithm, after learning from the data, machine learning algorithm is going to produce something called a model. That's what the machine learning model. From that, using this model, if I give some unseen text, unseen data to the machine learning model, the model will predict or categorize the input. Say for example, if I give the image cat image, the purpose here is if I say that whether it's a yes or no, then the output will be yes or no based on this mathematical model, right? So model is here. It's a numerical model where we have a lot of parameters in the model. This model replicate the whole behavior of this data, right? Similarly, language models, this model replicates the whole behavior of the language, right? When you say model, it's something automation also involved in it. It means that as I know, suppose you are teaching me Punjabi for some time, right? Okay, I'm listening. Now, how you know that whether I learned Punjabi or not? You may ask to speak some sentences, right? You may ask me to speak some sentence. You may ask me to translate something. You may ask me to read some. If I'm learning your Punjabi characters also. If you ask me to read the Punjabi letters, right? All those things are models, right? Same thing we are going to do the for machine. When I am teaching my language to the machine, I want to check how my machine learned, right? Now I'm going to ask if I give some sentences, how machine. If you ask me in a Punjabi, how I'm responding in the Punjabi, right? Where you are the two way you are understanding. One is you are understanding. You can always say that how I understand your language because you are giving a question in Punjabi, right? The second one, yes, ma'am. Okay, fine. So the one thing is you know that how I understand Punjabi, right? The second one is how I generate Punjabi language because I have to give answer in Punjabi itself, right? So the two things. One is language understanding, other one is language generation. All these things are part of language model. As I said that it's a world model, we are using this model in day-to-day life. In WhatsApp, if you say that, if you type the word good, the WhatsApp will give a suggestion. Am I right? The suggestion what I am getting and what you are getting will be different. It's a customized one. So we will call this as next word prediction, right? In Gmail, we are seeing that in a Gmail. In Google search, we are seeing that. Google search, if I type something, if I type few words, it's automatically suggesting what may be your next word, right? In our Gmail, if I type dear, it's suggesting that it knows that I'm going to say ma'am or sir. It's suggesting. If I type something as soon, it's giving something as soon as possible, right? It's a next word or prediction. So let's start from the next word prediction. This is moved to next word to next sentence prediction. Earlier, it started with the next word prediction or word prediction. Now it's moved to next sentence prediction, right? How it's related to the large language model, I'll come. So the basic language model explanation is given here. If you see that the cat sat on the mat, this is a pure probability-based thing. So the probability in the sense, first I'm saying that what is the probability for the word the first word? I need a sequence information here. So the next is I'm saying that what is the probability of cat? It's not only the cat I'm saying, provided given is a the. It means that first word is the. What is the probability that second word is cat? What is the probability that first two words are the cat, third word is sat? So remember the slight difference. I'm not asking the probability of sat alone. I'm asking the probability of sat given the cat because I know the first word and second word. Tell me what is the third word. I know first three words. You tell me what is the fourth word. So each word I am predicting, right? So finally, what I'm getting is I may get a sentence. Now you can say that I can relate this with the LLM. The LLM also doing the same. The LLM, you are look like the LLM is generating the whole the summarized output, right? But it's not retrieving from somewhere. LLM is good in generating. It's a generative AI model. So it's generating based on the knowledge what it's having. So while generating, the same way it will generate. First word it will give to the first word it will take output. From the first word it will give a second word. third word, fourth word, fifth word, like it generate. Right? So that's this what the language model and large language model. Now you can always ask, why? What's the difference? Language model and large language model, right? The difference is very important. Language model and large language model, not only in terms of size of the data what we used. The large language model is not bother about words. Large language model is interested in sentences. This is very important. Large language model is interested in sentences. I don't want to predict, I don't have time to predict one word. You give a sentence, I'll give a next sentence. You give a sentence one, I'll give a next sentence. That's what a large language model. Language model, you give a first word, I'll give a second word. That's what language model, the whole concept. Now the LLMs are saying that you give me a sentence, I'll give an extra sentence, right? Or you can consider this sentence as you give me a prompt, I'll give a response, right? You give a query, I'll give a response or answer, right? You pose a question, I'll give an answer, right? You give a document or multiple sentences. So I will summarize it, I'll give into one or two sentences. You give you give a document of multiple sentences. I'll translate into the record language what you want. You want the Hindi, I'll translate. So you can see that all these applications, all these things are comes under large language model, whatever we discussed. But the base is one. Base is sentence to sentence conversion. Your question is considered as a sentence. The model will consider the question. The model will generate what may be the next to that question, right? Not only the question answering. We may see that it's like a completing sentences, right? I'm writing two sentences of my email. I want what it can be a third sentence and then fourth sentence. My model can predict. My model can generate, right? It's a fulfilling that. So it means that it's not only for it's now we have a good computation power as well as we have a compared to the compared to the last decade, we have a huge amount of data. So rather than going for a word level model, people move to the sentence level model. That's what the output, what we are seeing, the ChatGPT. The best popular application for LLM is ChatGPT, Gemini kind of models. All those models are very good in doing this, right? So far, you remember, I touched only with respect to, I haven't said anything about the image so far. We'll talk only the text now. Image is a different model. The image models are called as multi-model LLM, multi-model LLM. Where the multi-model LLM means you can give an image as an input, you can give a voice as an input, you can give a video as an input, you can ask, you can give a AI generated video to the model, you can ask, can you check whether it's AI generated video or not? Have verified that. Even if you are giving some assignment related to the LLM, students will be very happy to do that. You ask a student to find some AI related images from internet, right? And you ask them to test with the different LLMs. How LLMs are identifying LLM is what? LLM is also AI, right? Whether AI is identifying that AI generated image or not, right? So that's the one. Okay, so that's a good exercise I'm suggesting. Fine. So this is what the large language models. What are the applications of large language models, right? Here, one important thing as I talked about the AI generated image. So I need to say that now, if you see that in internet, there is a recent statistic says that huge amount of AI generated content, right? It's not only in internet. Whatever report we are seeing from the students, whatever assignment they are submitting, accept their answer script provided if you are allowing them to write in a room without any digital environment, and then they'll write from their brain. If you give any digital assistance, then it's gone. That's from the machine only. I'm sure that, right? So now the recent survey says that the current last 2-3 years, the AI generated contents are more in internet, right? So in a future, in the sense in a few years after, so that will dominate the original human generated content. That's a very serious concern. So far the LLMs are good. The reason is the LLMs are trained on human generated content, right? How the LLMs are trained? They are just taking the all internet data and then they are feeding to that LLM. Before LLM, we don't have any generative system. We have only spell checker or grammar checker maximum, right? So all those sentences, whatever there in the internet, I'm saying 5 years before, all are written by human brain, not only English, any language, right? Human brain in the sense your brain generated, some brain generated the sentence, natural intelligence generated the sentence, right? Now everywhere we are seeing a human generated sentence, right? I have seen that on popular conference review, the reviewers are very lazy nowadays, the research, right? They are just giving the research paper to the model AI, and then they can ask the AI to give a LLM to give a review for this paper, right? They just copy the review and then they're submitting. It's not only I'm saying that the students are using AI, the faculties, researchers also using the AI in their level. Students are using for assignment, faculties are using for this purpose, something like this, right? But there are, as I said, that there are good and bad in everything, right? So which one we are going to concentrate, where we are going to limit yourself is a very important, because I used to say in class, so when you start the very important thing of neuro exercise, in the sense the brain exercise, is actually writing or reading or talking, right? Because when you see that when the kids, first thing the kids is learning, the kid brain is grown up, the first thing is kid try to talk a language, right? Kid try to put a words together and kid try to speak something, kids try to understand something. So the language, the brain starts evolving from language, right? So the point here is, when you are talking, when you are writing, when you are speaking, it means that you are giving some exercise to the brain, you are activating the neurons in your brain. So that will help you in generate, then in critical thinking, that will improve your reasoning skill, all those things, right? Now if you stop, say you are not now after the phone, if you see that people are not digital, the faculty is not in a class, earlier days there will be a lot of sound, lot of noise. Now the faculty is not in a class, everyone is silent, all involved in that, they all go to the digital era, all are taking the mobile phone and then all are concentrating that. So the talking itself, it's a less, right? The interaction, social interaction is less. People started using the media, social media, and then shorts and other things. That's the one thing where you are not talking. It means that you are not talking means you are not using your brain neurons, you are not activating brain neurons. You are not writing also, because ChatGPT is writing now. You are not writing your own sentences. Small mail, if you want to brief, you can take a assistant, you can take a help, you can write an email, you can ask a ChatGPT to improve it. That's a good way. If you completely depending on ChatGPT, you are not using that particular part of your brain, right? That definitely, there are researchers, there is a research study from MIT says that affects the human brain drastically, right? Because of this AI systems, now AI started learning. AI intelligence is more because you are giving a lot of input. All your query is input to the AI models. The intelligence of the AI is increased day by day. The intelligence of the human is reduced, right? Because we are not using the brain. Even a student is very good in writing. So you just think about yourself. Even you just take my example. I'm not blaming you or the student. Even I just say that. If you ask me, I used to write without spelling mistake earlier. Now, if you ask, I'm seeing that I'm making spelling mistake. It means that it means that we used to write in a digital platform, or where there are automatic tool to correct ourselves. We least bother to correct ourselves. Okay, even I wrote in a spelling mistake. I wrote any mistake. I mean, even I have even I just made. I mean, even I made a mistake. There is an automatic tool to correct. Final mistake. I tried one a few days before. I asked my son asked me to write an essay. So I try to help, and then I try to write after a long time. I'm seeing that I'm making a lot of spelling mistake. I'm making, right? So it means that when we are not using that particular portion of the brain, and then our knowledge, whatever we learn, we are forgetting, and then those things will affect our critical thinking and all those things, right? So my kind suggestion, you teach the young generation, that you make them to understand the importance of the AI, as well as how, where to use AI and when to use AI. That is very important, right? Fine. Okay. So when we are talking about the LLM, I said we started with LLM and then we went somewhere. So whatever I said is an example here. Sentence correction, right? Text completion. I'm writing some text and the model is giving something. I'm making mistake in a sentence. The model is correcting the sentence. I'm writing something in English. I'm getting the output in the Punjabi text translation. All these things are part of language model. Now those things are extended to large language model. So I'll just skip these things. Now a small exercise to you guys, right? So I guess you guys are active now. Fine. Okay. So I'll just put up the question. Now I'm showing one image. So I'll just see that I have a say once again. Okay, fine. Yeah, sorry. So okay, so this is the one image I'm showing. I'm telling that as encoder. Take 30 seconds and understand this image. After that, I'll tell that what is the task, and I'm showing this the image. After that, I'm going to show the decoder image. I'm going to ask you to find the difference, right? So encoder, take 30 seconds, understand this image, and concentrate on the connections. Right? This is encoder. Next, I am moving to something called decoder.
Got it, sir.
Yeah. Thank you, sir. Now I want someone to say that difference between the first one and second one.
Yes, sir. In encoder, we
Yes,
can
sir.
see that the third layer that yes, sir. In third layer, in first
Okay.
row, second row, third row, I can say three that TM are there, and
Yeah.
one to all connections from bottom up to
Okay.
all actually, sir.
Yeah. One to all. Correct.
One to all.
One to.
But in the decoder, we can see that first
Yeah.
one is containing one to all. Second is again from that to rest one all. And
Ah.
similarly, last
Yes.
one will be connecting to the last one. That
Correct.
means n
Yeah.
to n to all, and then
Hmm.
n minus one, then n minus two, and so on till one.
Correct. So good observation, sir. So your answer is 99% correct. 1% I'll just fill the things. What you said is exactly correct. Good observation. So where one to all. So one, the TRM means a transformer. So this is connected with every layer. Here, if you see that this is connected to only the future. I'm starting from 1, 2, 3. Like it is connected to only the future, right? It's not looking back. It's generating the future, right? Here, if you see that the future is coming back and then helping my the second word, you consider this is a word. Second word is coming back and then helping my first word. Third word is coming and then helping my first word. Fourth word is coming and then helping my first word, right? Here it's not like that, right? So it's a kind of one directional. So this is going in a left to right, where I am generating the first word. From that, I am generating the second word. From that, I am generating the third word. So I am moving like this, right? Earlier is not like that. I can use, when I'm learning about the first word, I can use W2 also. I can use W3 also, right? Now I'll come back to the encoder decoder. Here the encoder means the query, what you are giving is an encoder. The response is decoder. It means the query, whatever you are giving, say for example, you are asking ChatGPT, you are asking a query, right? So that is that the query, when I'm giving this query to the ChatGPT model, large language model, I know the first word, I know second word, I know third word, fourth word, fifth word, sixth word, right? But while generating the answer, I don't know I don't know the suppose for this 10 words, I'm going to generate 7 words as an answer. Example. I don't know 7 words immediately. I won't get the 7 words. How I will generate is, I'll tell, this is a very important thing. First, I'll generate the first word, decoder. This is the encoder. Encoder is for understanding the 10 words. The point is actually, when I'm understanding the 10 words through encoder, I can take this 1 to n link, as sir said that. 10th word also I can take the link with the first word because I know all 10 words. I can put a 1 to 10 connection, 1 to 10 connection, 1 to 10 connection 10 times because I know 10 words. But as output, I don't know what is my output, right? First, I am generating the first word, right? First, I am generating the first word. So now I know one output, right? I'll explain here. First, I'm generating the first word. I know one output. Now I'm generating the second word. While generating the second word, I am taking the help from the first word. Hey, you also come. So because when ChatGPT is generating the sentence as output, it should be grammatically correct sentence, right? Grammatically correct sentence. Grammatically correct in the sense parametric architectures for text completion. I am telling. This is I'm saying grammatically correct. I cannot say that parametric parametric completion text architectures for ChatGPT is supposed to generate any model is supposed to generate LLM supposed to generate the proper fluent English sentence. So first it will generate any language sentence. First it will generate the parametric, then it will generate the word architecture, second word. While generating the word second word, I have to refer the previous word also. The reason is I need to maintain the sequence, grammatically correct sequence. Now, while generating the third word, I'm taking the help from the first word, second word. Hey, these two are my first words. You remember that language model I said, no? Hey, these two are my first two words. You tell me what is my third word and what is my fourth word, what is my fifth word. So slowly the model will move. That's the concept of decoder, right? So one second. Yes, ma'am. Any questions? Okay, fine, no problem. Yeah, so this is what happening. If you see that the encoder and decoder, the encoder try to understand your query completely, and encoder understands the query completely. Suppose this is the response to your query. Sorry, I'm very bad in drawing. Okay, this is a response to your query. So I have a query. With respect to this query, what is the first word? First word I'm saying parametric. Okay, fine. With respect to this query, as well as this first word, what is the second word? I'm telling that the second word is architecture. Fine. With respect to the query, with respect to that first two words, what may be my third word, right? So that's what the diagram. If you see this diagram, whatever I say that it's same. First word I'm giving, first word, second word I'm giving, all other words I'm giving. The model is identifying that what is my nth word. So that's the reason decoder is not having the direction, the connections like this. All right, fine. This is the main difference between the encoder and decoder. This is a very simple architecture of this. Talks about the whole LLM. You are giving a query as an input, you are getting response. As I said, query is given to the encoder. So encoder is converted to the encoder information is given to the decoder. Decoder is generating one word as the output. Finally, I'm getting output as a sequence. What you are seeing in a chat GPT model. Yeah, yes, it's a sequence. So input you are giving and you are getting output as a sequence. This we know, neural language model. We have seen that word to vec, right? So the before session we have seen that. So I am skipping this. So this is the foundation of that. Okay, now I said about 2013, the Google invented word embedding word to vec. The person behind that word to vec is called Mikolov, and then he invented this. So then just to see that 5 years, what happened to that? So after that, there are a lot of word to vec models. This is also word to vec models. Glow, this is from Stanford. Fast Text 2016 from Facebook. And yeah, so these are word level models. So people are not happy with the word level models. The reason is, suppose if you take the word bank, you know that the bank is having two meanings. Ma'am given one example, the word mouse. Mouse is having two meanings. One may be the rat or real mouse, or one may be the computer mouse, right? The word to vec will not differentiate that. If you give a word mouse, word to vec will always give a generate a single vector representation, right? It means that even though I'm taking the context, word to vec is telling that I have all information in my context. I have the information about computer mouse in the same vector space and have information about the animal or the rat also in that thing. But I want two different things. What I'm saying to the word to vec is that may be useful for the word level. But when I go for a sentence, with respect to the context, if I use the word computer, if I use the word printer, if you're seeing that, when I'm telling the mouse, I want a different numbers for the word mouse, right? If I use the word related to house and the cat and mouse, I'm saying here I want a different word in different vectors related to this mouse, right? How to do that? Researchers think that. So people come with a model called contextualized embedding model. So this is the without context. Even though the context is there, this is a word level model. This context is slightly different. You see that we'll understand that when I say the example. What is this contextualized embedding model? Fine. In this, there is a famous, very popular paper. If you are doing the research on this particular domain, or if you are interested in learning more about LLM and other things, I strongly suggest you to make a note of this 2017 paper. It's from the Indian Ashish Vashini. So Vashwani. So he made up his paper, very popular paper. Attention is all you need. This paper talks about something called a transformer. This transformer architecture is only used in all ChatGPT kind of models, all GenAI models, starting from GenAI, Llama, or the GPT model, ChatGPT, all the architectures, even the Cloud, all architectures, Copilot, all the architectures are Gemma or BART, all architectures are based on this transformer. This is a popular one, right? So we may not have cover it. I'll say one or two slides I have to explain about the transformer, right? I'll go now. I said contextualized embedding, right? So I'll give an example to understand. You see that this is a Elmo. This is called Elmo. You consider that as a software, or let's say it's a kind of bot. So a human is asking, hey Elmo, what is the embedding? Embedding means we have seen no first session, the numerical representation. What is the embedding for the word stick? If I ask the same question to the word embedding throw a 300 dimension vector, right? But now Elmo is a context information, context based. Elmo is telling that, hey, there may be multiple possible embeddings, right? For the word stick, multiple meanings. I'm asking, use it in a sentence. Now I'm giving that. Let's stick to improvisation in this kit. I'm telling the sentence. Now Elmo is giving the embedding for that, right? So this is a difference. It means that if I give a different example for with respect to a stick, I'll get a different embedding. So this is like a call, we can call this a dynamic embedding, context-based embedding. So you no need to worry about the meaning of the word. The earlier the problem is, as I said, mouse will have only one embedding. Here, mouse will have two different embeddings. All right, based on the context, how we used. So this is what the context-based embedding. I'll just skip this Elmo. I'll go to the transformer. I'll spend some time on transformer to explain that. Yeah. How we are doing this? How we are getting this context information embedding? So see that I have word stick. You remember in word to word, I have a context, and I'm using some one neural network algorithm to get this word, right? Context and then word. Here I have a set of words. It means a sequence. I have a nearby words. Let's stick other words are there, right? So all those words I'm learning with the help of the popular architecture called here LSTM, right? The LSTM is used in this first. Initially, the people used LSTM. Later, they removed this LSTM. They moved to something called transformer. You remember that I used this term TRM we have seen in encoder decoder. TRM is transformer, right? So how this embedding is created? First level embedding of a stick, right? First level embedding. Second, because there are multiple layers, two layers. So second layer of a word stick and third layer of the word stick, right? So all are concatenated and the weightage is given, and finally the weighted sum is the vector for the word stick, right? Don't worry much about this one if you're not understanding. So you remember, as earlier we are using only single layer, so only one W is there. Here I'm using multiple layers, so I'm getting multiple vectors. I'm just using some weightage I'm giving to combine this vectors, and I'm getting the final vector. This vector I'm calling it as a word vector. This is a Elmo. So now the popular model of the transformer model, there is something called BERT. So this is called first large language model. This is the first large language model. BERT means bidirectional encoder representation from transformer. Now this the T talks about the transformer. As I said that all these models, GPT, generative pre-trained transformer models, all are transformer models. All now, the recently we interacted with a top a person in India. So, what is the future of the models? How we can fine tune or improve the models? His point is only one. He's telling that all models, whatever we are having for last 5 years, are related based on transformers, right? If you want to move from transformer to some other, if people invent some other thing to the transformer, that may be the alternate. So we may do a lot of new invention from that, right? Because now if you see that LLMs are like a kind of saturated, the new LLMs are not coming now, right? The reason is the only the only popular successful Gen AI thing is ChatGPT or GenAI, the other question answering conversation system. I'm saying product wise, so far, most of the companies implemented that, and then very few companies are succeeded developing a successful product with the help of GenAI, right? That's a very That's a very sad truth I want to say here. So it means that we have that we have that system, but when it come to that application, we'll say when it come to the medical domain, when it come to the other let's say legal domain or other domain, when they started building the products are not successful like ChatGPT. You see that how ChatGPT is successful. Like similar to that, why we are not seeing a lot of generative AI models? The reason is that accuracy of Gen AI models. Gen AI models are very good in generating sentences. We have a limited, we have very limited requirement for generating sentences, right? We want something more in the other scenario. Say the generating sentences in the sense summarization also it's doing the generating sentences. Email you want generating sentences. You want some code, you want a Python code, generate sentences. You want TensorFlow code, generate. I mean the same way how it's generating the sentences, it's generating the code. Okay, so the bird invention is something people used to say that it's a ImageNet movement. It's a popular ImageNet movement. I'll skip as we don't have much time, so I'll just skip this one. So this is a bird architecture. So the 2 point is important here. We already discussed that masking, right? We have seen the example of love, right? Same concept. The two words are masked here. Earlier I masked one word, they masked multiple words because they are going to learn from the sentences. They masked multiple words. The next one is, I said about next word prediction. Here there is something called next sentence prediction. Ajay is a cool dude. He lives in Ohio. The next sentence, I'm going to check that is it a next sentence is true or not, right? It's called a next sentence prediction. Masking also we have, sentence prediction also. The same thing extended to this BERT model, right? So where we can use it, question, I'm getting the answer, right? Question, I'm just giving the question and then I'm getting the answer. But you can give a passage also. Earlier models, now the current LLMs, you no need to give a passage. Earlier models, you can give a passage. Hey, my question is from this particular passage. You answer it with respect to the passage, right? So now you can write it in a prompt itself. You can add this as a passage in large language models. We have a provision to add that. So this is about architecture. I said about mask language model we have seen. Next sentence prediction. Both we discussed already. So I'll skip this. Yeah, this architecture also we have seen. So the encoder, this is decoder. So interestingly, all GPT model, you know what is OpenAI, right? All the GPT is from the OpenAI. All GPT models are from OpenAI. GPT 1, 2, 3, 4, even 4.5 is there. Multimodal GPT is there. Visual GPT is there. All are from OpenAI. The product which used the GPT models, or we are calling it as Chat GPT, right? Yeah, this is the transformer architecture, what I said, 2017 paper, right? 2017 paper from Ashish. The attention all you need. This is about the paper. This is a Chat GPT architecture. You see that? Same thing. Layer normalization. Layer normalization is there. Multi-self attention, multi-head attention is there. Masked multi-head is there. Feed forward, everything is same. That's what I said earlier. The architecture is old, 2017 architecture. So the only thing is have a huge amount of data and computational power that they have 12 layers of that. If you see the earlier example, we have seen only the 2 layers, right? Here 12 layers, 12 cross, 12 layers like this, 12 transformer layers are added. So that's the reason it's giving a very powerful result. So I'll skip this transformer, how the transformer things are there. Anyway, I'll share the slides. The mathematical things are there. So I'll just skip those things. Okay. So this is the transformer architecture we know. Earlier one is a ChatGPT architecture from OpenAI. This is Llama architecture. Any guess that Llama is from who developed Llama? participants? Llama is from? Llama. ChatGPT means OpenAI. Like that, Llama. Any answers? Llama is from Facebook, right? Llama is a Facebook model. I guess you guys are tired. Okay, Llama is from Facebook. So the other popular models, I'll say that there is something called T5. T5 can translate English to German, English to any language. It can give two sentences and then can say that the sentence is acceptable or not. That mean the sentence is correct or not. And I can give a two sentence and then I can ask that how much similar the sentence is. I can give a paragraph. I can ask a T5 to summarize, right? So it's a popular model, Transformer 5. Okay, now the LLMs are different. So you agree with me, I guess. No students are coding by themselves. That's a sad truth again. Only 10% are coding by themselves, right? Remaining are depending on ChatGPT. Earlier, when we are doing earlier, this is a 2018 and 23 scenario. Now the scenario is completely changed. So earlier we used to change the parameters like the dropout activation. Now we are playing with a prompt, right? So we are giving a text prompt, we are getting a sentences. Sorry, we are getting the code. So what are the drawbacks of this? We'll just see some drawbacks of that large language model. We can say that ChatGPT limitations. So it may generate incorrect information. Incorrect in the information in the sense fake. It may or hallucination. I can say that this is called a hallucination. It may hallucinate. Hallucinate in the sense, suppose you are asking about to write about a essay about a Gandhiji. 20 lines it's writing about Gandhiji. In between one or two lines, it is talking about suddenly it's talking about Subhash Chandra Bose, right? Then it's a false, inaccurate information, right? So that is called a hallucinate because that's a main drawback of ChatGPT model. Now they control actually what we are using is the currently they focused more on avoiding hallucination as well as that removing the bias. But still, I feel that we have hallucination and bias. The next one is bias, right? We are working on this important thing actually. This is a bias. Say for example, if I say one particular state of people, the model will, and if I ask the model, what do you feel about these people? The model may say that, oh, there are a lot of terrorists from that particular state. The model may say that, okay, the person terrorist. That is a biased, right? Who is the model to take decision? Because the data is like that. There is a huge amount of data given to the model. The data is like that, so model is behaving like that, right? And if we ask a model to give a photo of nurse, the model will give the female nurse, right? People are telling that it's a wrong, but if you see that why it's a wrong, it means that there are a lot of nurse images given to the model to train, where when I give that the male nurse images are very less, female nurse images are is the majority class. That's the reason model is generating, right? So it's a bias, but this bias is not a harmful bias. Certain bias are harmful in nature, right? Certain bias will destroy the legal system. Say for example, if you give one particular religion people legal document, I am saying that if you're giving and then if you ask the model to predict the judgment based on that person name, the model will give a judgment. It says that, hey, this person name is look like this particular religion, he involved this particular religion, people may be involved in a lot of other things, so the judgment will go reverse of it. If you just remove the person name from the same crime, what the crime is saying, you are removing that person name and then you are giving the different religion person, same ChatGPT model is telling that the judgment is positive, it's not against you, right? That is a harmful thing. That is a bias, right? The model or any AI system should not take any decision based on the person name, right? It should take a decision based on that crime. That's a purpose, right? So the importance or attention should be given more to that crime rather than the person name or the person demographic feature or the other profile information. The earlier ChatGPT have that in the issue. Now they corrected that. Now they added the RAG and then they modified it. The earlier models are having the limited knowledge. Okay, so this is we have seen that. So this is about the multi-model large language model. So you can see that image I have uploaded, and I'm asking what is the picture. The model is telling that looks like a duck. I'm saying that that's not a duck. Then what it is? Model is telling that look like a bunny. I'm asking that why you are telling that it's a bunny, and it's saying that it have bunny ears, right? So the model assumption is the each one. This is called a reasoning. You can ask a model to give a reason for that, why that is, right? So it's a reasoning. So this will improve the transparency as well as explainability into the models. So this is based on the something called vision transformers that will add image plus text. As I said about the ChatGPT, have something called the visual ChatGPT. This is a little old one, visual ChatGPT model based on images. Now the current GPT itself doing the visual ChatGPT. Yeah. Now this is a very important thing. How with respect to the size in 2019 and 18 period, if you see that BERT is released with the 340 million parameters in 22. So the Megatron is the size of the large language model parameter, 530 billion parameters, right? This is the other challenge. You cannot use that Megatron in your local machine. You can just use it as a API call or something. You cannot fine tune, you cannot improve further, right? 340 million parameter to 530 billion parameter in a 3 years range, right? This is a drastic exponentially the increased the number of parameters, right? So we are here, we talked about the BERT, right? After BERT, there are a lot of models in within the 4 years from 19 to 23. If you see that some popular models, you may hear about DALI 2 and Flanty 5 is a popular model. All are LLM large language models. GPT models are there, GPT 3, Debata, Robota. I said about the vision transformer models, right? And the POM is also another popular model. You see that how the ChatGPT parameters are increased as well as a task. Initially, the large language models are only for language understanding and question answering. Slowly, people added for summarization, joke explanation, translation, all those things, common sense reasoning. So we are building on top of semantic parsing, uh, understanding the proverb, explaining the proverb, generating a new proverb. All those things are happening, right? This is with respect to the size. You see that, like in a galaxy, how our Earth is. This is a BERT. I said no, very popular model. We used to call this the first large language model. The size is BERT of like this, and you see that bigger model POM. It's a 540 billion parameters. Parameter in the sense, I said about 300 size vector, right? 300 size vector in a word to word. It's for one word. Like that, they have 540 billion parameters as they're covering lot of, multi-language and then multiple words. So all those things are extended from BERT, video BERT, multi-BERT, and all those things. You can see from here 2019 to 23 how the LLMs are emerged. So this is from the OpenAI, and this is from the Meta. Llama is from Meta Facebook, right? And you can see Amazon also having something called Alexa TM. Code Gen is there. India is having something called the Bharat Gen. September, India sanctioned around 900 crores to development of the Bharat Gen. Soon we may see that the India specific Gen AI model Bharat Gen. So IIT Bombay is working on it. So I'll skip this and I'll come to that. We know that hallucination is a one problem, and bias or misinformation, it will give a fake information. You should not trust, right? So we can see the examples here. So you can see the examples. LM can be attacked, right? You are giving a prompt. A prompt can be injected with some other additional prompt. So to confuse you or to poison the text, right? So those are the drawbacks of LLM. There is, you may know about this guy, right? Sam Altman. This is the CEO of OpenAI. So his statement in 2023, so 2 years, 2.5 years before, around going to be 3 years, the intelligence in the universe doubles every 18 months. The amount of intelligence doubles in every 18 months. This is a statement 3 years before, but now this may be 12 months, right? And importantly, he haven't said about whose intelligence, whether it's a machine intelligence or human intelligence. Obviously, I feel that it's a machine intelligence, right? I'm not saying the human intelligence is human intelligence also. I mean, it's not doubling that, right? So maybe he's talking about machine intelligence.
Sir, actually, AI is becoming more powerful than human.
Yeah,
Yeah, after
I'll come to
every
that.
12
We
months.
have a concluding remark to that. I'll come to that. So anyway, I'll just conclude it, then we will discuss it now. Yeah. So you see that one side, if you use a ChatGPT, without ChatGPT, a developer is doing a 2 hours of coding, and debugger is debugging the code for 6 hours before ChatGPT. After ChatGPT, developer is only spending 5 minutes. They are giving the right prompt and then they are getting the code. But debugger is spending 24 hours to debug the code, right? To understand the code, because we cannot expect the ChatGPT always will give a right code. Okay, so one point here is, so how can we develop a similar system for Indian languages? As it's a language problem, then you can relate that it's a societal problem. And one more thing is how we can add explainability and interpretability in a large language models. So as these models are really open source, no. So how can you go for this multi-model, adding audio and video and all those things? How can you develop something in your local mission? So those are the upcoming things you can focus on it, right? The final point is actually people are now started talking about something called small language models from 2024. They are not talking about large language models, because you cannot use large language models. You cannot fine tune in your mission, local mission. So they are going for edge based AI. Now the edge AI is coming. So they want something in the local device. So the small language model is coming up now. Okay, so with one statement, I'll stop now. So Llama is a
Hello.
popular meta
May I
ChatGPT
audible?
model, metas model. Yes, sir. Okay, Meta is a popular model. So sorry, Meta's popular one is a Llama.
Hello, may I
Meta
audible?
was telling that, sir, talking to me. You give me 2 minutes, I'll conclude actually. So, ma'am asked about the intelligence, right? The answer is here: the intelligent, human intelligence, other things. So, the Meta Llama is, the CEO is telling that 1/4 of internet data is given to the Llama. You see that whole internet data, 1/4 of internet data is fed to the Llama. How powerful you see that? So, if a human need to learn that 1/4 of internet data, we need 22,000 years for a human to learn from that 1/4 of internet data. We need 22,000 years, right? You see how A is powerful. A may took only a month to learn that, but you need 22,000 years. At the same time, I'll put other direction. So how much time for you to you to learn a car, learn to drive a car? Maybe 2 weeks, maximum 4 weeks. 1 month is enough. You can learn, right? But what makes the AI too difficult? Why the AI is not coming with a why we are not seeing the autonomous car in the last 10 years, right? Because the research happened. Elon Musk started long back, right? So the point here is certain tasks, always humans are good, certain tasks, machines are always good, right? But we have to see that where to use machine properly. Machine should be always assistance to you. A should be assistance to you, right? We should not be assistant to the AI. As we are feeding a lot of inputs to the AI machine, it means that whatever the query you are giving, the query is stored in a somewhere, and then the AI is learning from that query, right? The intelligence of AI, the intelligence is day by day it's increasing. At the same time, our intelligence, our dependency, our critical thinking, all those things are reducing, right? So with this, I'll stop the last slide. If you have any questions, I'm happy to answer. I think I've taken up 5 more extra minutes. Okay. If you have any questions, I'm happy to answer.
Thank you so much, sir. I, Dr. Sheprajan, on behalf of GNIM, would like to express my sincere gratitude for delivering such an insightful and enriching session. Now the floor is open for the queries. If any participant has any query, please raise your hand or type it in the chat box.
Hello, sir. It's again myself, Nilesh Dokania, sir.
Yeah, yes, sir.
Sir, one just question. Actually, in between, when you were, explaining that probabilistic, numerical values after changing from the word, like say zero point 0.7 is given to someone, 0.1 is another one, 0.1 is another one, and then zeros are there. Then you placed a thresholding value like highest one is 1, and then all will be zeros.
Yes.
Yes, sir. My question was that if say, sir, some 2 3 values are equally weightage, like zero point 0.4 zero point 0.4 and then zero point 0.1 zero point 0.1, say, then what will be the, because leading one will be only one, as only single one is there and rest will be zeros, then
Yeah.
how you will be giving the probabilistic value the more than one values to same?
Yes. So good question, sir, actually. So as you know that the machine is handling that, algorithm is handling that. So you ask the right question that I have two probability values, or I have two values are same, 0 0.4, 0 0.4. My model will take, say for example, out of this 0 0.4, 0 0.4, one may be the word like, one may be the word love. If model chooses like, it means that there is a error. Then I will change the parameters. Again, I'll come back. Then if I change the parameters, what will happen? This 0 0.4, I am saying that is an error. So the importance of the 0 0.4 will get reduced. The 0 0.4, next time when I coming, the first 0 0.4 will become 0.3, and next 0 0.4 will become 0.5. If I choose the wrong. Otherwise, I have an option for the model to choose the right one. If I choose the right one, obviously I choose the second word love. The model is already chosen the right one. The parameters are fixed. Right?
Sir, one
I
question
hope,
in the chat
Yes,
I
sir.
box.
answered.
Got it, sir. Thank you, sir.
Yeah. Thank you, sir.
Sir, there is one question in the chat box.
Yes,
What
ma'am.
about the accuracy of AI
Yeah.
models?
Yeah. I said about the accuracy when we discussed about itself, I added the accuracy, right, ma'am? So I said one point that where ChatGPT is a one popular Gen. I'm talking about the AI is a very big thing. I'm talking about the Gen AI models, generative AI models. In generative AI models, ChatGPT is a one popular one. What we are using, we are not seeing any other product with any other accurate product. Lot of companies are failed to develop accurate product with the help of Gen AI, right? But AI are in other places. AI are there. As I said that always we should keep human in the loop. Say medical, if you say that medical things, we cannot depend completely on ChatGPT, right? So I'll give you one small example. When we are, as a researcher, we know about the accuracy. If you see someone says 99.99% accuracy, we'll be happy. Oh, you got 99% accuracy, right? But you just to see that the flight, I'm saying, I'm just saying about the accuracy level of the say the flight as well as the aerodynamic system, right? If you say 99%, the accuracy level in the sense, safely you will learn, safely the flight will be landed, or the flight will be taken up. 99%, if you say that 1%, the whole world will be 3 lakh 3 lakh human lives. If I say 99%, daily I'll get a information, daily we'll get a news that 3 lakh people expired due to that 99% accuracy. So where in this particular system, I want 100% accurate, right? Similarly, medical also, I want 100% accurate. So what I suggest, we cannot completely given to the AI. We need a human in the loop. We need expertise. Whatever machine is giving that, we need some expert to vet that and then to make it to the decision-making process. I hope I answered Kalpana Prabhakaran.
Yes, sir. Any other query, participants? Okay. As we come to the end of today's enriching session of our faculty development program on LLM, large language model, I would like to take a few moments to reflect the key highlights of today's session. Sir has given a deep knowledge on LLM and their underlying principles. Sir has explained the LLM's function, the role of word embedding, distributional semantics, and the mathematical foundations such as singular value decomposition used in building these models, also roadmap to LLM, power to word embedding, distributional hypothesis, language models, theories of language models, and Llama architecture. So, and many more. All the part, yeah. So we are truly grateful to you, sir, for an enlightening and though provoking session that deepened our understanding of the topic LLM. Thank you so much, sir. To express my heartfelt gratitude for conducting such an informative session, I request Dr. Anand Kumar, sir, to accept the memento as a token of appreciation. We look forward to... Sir, please accept the memento.
Yeah, thank you, ma'am, thank you. Thank you once again. Thank you for organizers, as well as thank you for special thanks to participants. So even I have taken I know that how difficult in a 6 to 9, even you guys are very active. Thank you very much. Thank you, Nilesh. Special thanks to Nilesh sir, as well as Mamta ma'am.
All the
Thank you, sir.
participants are requested.
So nice of you. These words from your side means a lot, sir.
Thank you, sir.
All the participants are requested to turn on their video for group photograph. Participants, please.
Thank you, Dr. Anand.
Yeah, thank you, ma'am.
It was really a very informative session, and I was all through there. And the doubt I had, it is a long session, but it was not at all boring. Believe me, it was very interesting, and it kept us stay tuned. And just we were thinking that how it should not happen that we after the break we miss any of your model or any explanation to any point. So that was very nice connecting with you, and I hope everybody must have been given the opportunity, got the opportunity also to understand and to learn more from your all wisdom and shared in this platform. Thanks a lot, sir. Thanks a lot.
Thank you once again, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thanks to all participants. Thanks to all GNM team for being on tuned up and.
Hello, sir. I am Dr. Pankaj Kumar Vashne from IITM.
Yes, sir.
Thank you so much, sir, for nice explanation.
Yeah, thank you, sir. Thank you.
It is rich for research purpose. We can include in our.
Thank you all. We look forward to seeing you all again tomorrow at the same time. Thank you all.
Thank you,
sir. Thank you, ma'am. Thank you all.